Okay. Very good afternoon and welcome back to the virtual coaching classes conducted by the Board of Studies of the Institute of Chartered Accountants of India. Today we are going to take up combinations. I'm sure all of you are keeping fine, and even though the pandemic continues, but life is going on as usual and we are all studying and improving every day. And I hope the sessions for all the subjects must be very useful for you in your preparation for the CA Foundation exam. Well, last day we did number of problems on permutations. Today we shall be taking up combinations, but before that, little review of what we did in the last day. I am also very happy to know that many of you have written and said that you are following the classes, you are finding it useful, plus you are having not much of problems with the chapter of permutations because we have only one formula, not much to memorize, but lots to understand, and we have to apply our mind, especially for the problems involving permutations and combinations. Well, as we discussed last day, permutations is an arrangement or a selection. It's an ordered arrangement, of course, and we took an example last day of ABC, and you can write ABC in different ways. It could be ACB, it could be CBA, it could be BCA, and therefore these are different type of arrangements. And permutation is an ordered arrangement. It is a system in which different objects can be arranged in a meaningful way, and the idea is to select, and permutation also means options or the number of ways in which you can select objects. Plus, friends, we also discussed that permutations and combinations are similar to the extent that both deal with arrangements. But when you look at permutations, the order, so if I write AB and BA, the orders are different. The letters are the same. It is AB and BA. But if you see, the order is different. And in case of permutations, the order is relevant. However, in case of combinations, the order is not relevant. The order in which they appear, these letters appear. In case of combinations, it is not relevant. That means in case of permutations, this will be taken as two sets. But in case of, this is in case of permutation, P. But in case of combinations, these will be taken as one set only. In case of combinations. So please remember this simple difference between permutations and combinations. Friends, we also saw two important points here. First is, we saw that permutation formula is written as NPR, and here we are selecting R objects out of N, and the formula is N factorial divided by N minus R factorial. Friends, factorial means, quick recap, N factorial means N into N minus 1 into N minus 2 in this way till 3 into 2 into 1. So this is what is meant by N factorial, and some of you have asked a very interesting question. That is, that day I discussed that 0, factorial 0 is 1. Now why is 0 factorial equal to 1? Thanks to many of you who raised this question. Now 2 points here. 0 factorial, factorial 0, if you see, is 1 by convention, by definition. First. Second is, what is 0 factorial? If I say what is 2 factorial? 2 factorial means in how many ways can you arrange two objects? If I ask you 8 factorial, 8 factorial. Say there are 8 letters A, B, C, D, E, F, G, H. In how many ways can you arrange them? So we use 8 factorial. So 8 factorial means in how many ways you are able to arrange 8 objects, 8 different objects. In this case, letters. But if I say 0 factorial means what? In this case, m is equal to 0. That means in how many ways can you arrange 0 things? 0 factorial means that. In how many ways can you arrange 0 things? In other words, how many ways, in how many ways can you do, if I ask you 5 factorial, I can say that in how many ways can you do 5 pieces of work? In how many ways can you arrange 5 objects? But if I ask you 0 factorial, it means in how many ways can you do 0 piece of work? That means how many ways in which you can do nothing. 0 means nothing. So 0 factorial means in how many ways can you do nothing. And by mathematical definition, the mathematicians agreed that 0 factorial must be equal to 1. By convention, by definition, to make it meaningful and to make this concept consistent. Friends, you know the fundamental principle of consistency. So, to make mathematics consistent, comparable, and not so that it does not end into something which is hodgepodge, right? That is the reason why 0 factorial is taken as 1. Of course, 1 factorial is also 1, right? Now we also looked at the multiplication rule in the last day. We also looked at the addition rule. You may remember that multiplication rule deals with 2 different events or 2 different pieces of work. That means if I have 5 ways or 5 buses, I took the example of buses, 5 bus routes for going from my residence to my office, and I have got, say, 3 ways to come back, to return, right? And how many ways, if I want to go back from my residence to my office and to come back from my office to my residence, in how many ways can I do it? So, this is a case where to go from my residence to my office, I have 5 ways, and to return from my office back to my residence, I have 3 ways. So, this is the m into n rule, that is 15 ways. So, this is the product rule, or also called the rule of multiplication. Next, we had the rule of addition. You can see here that we have multiplication. It means there are 2 different events and they are connected. They are interrelated. They are not independent of each other, because if I go from my residence to my office, only then I can return from my office to my residence. Right? So, this was the basic example of multiplication rule. Coming to the addition rule, same thing but little different here. If you have m ways of going from your office to your residence, m ways, and I mean to say m ways, say by metro, m for metro. You have 5 metro routes, or let's take it 4 metro routes. You have 4 metro routes to go from your office to your residence. So from office to residence, I have got 4 metro routes, and I have got 3 bus routes. All are different. The metro routes are different and the bus routes are different. So in case I have 4 metro routes and 3 bus routes for going from my office to my residence, then in how many ways can I reach my residence from my office? That is what is called the m plus n, the addition rule. So in this case, it is 4 plus 3. That is 7 ways are there. So this is the addition rule. And in the numerical, some of you were asking how to identify whether to apply the multiplication rule or whether to apply the addition rule. Just by looking at the wordings in the problem, just by looking at the language, if you see there are 2 independent events, which are 2 dependent events which are connected, right? They are linked with each other. One depends on the other. They are dependent events. In that case, we apply the m into n, that is the multiplication rule, In other cases, when you find there is only one event, one piece of work to be done, one arrangement to be done, in that case we will apply, if necessary, we will apply m plus n, that is the addition rule of permutations. Okay, so this was basically the addition rule and the multiplication rule, and I am now giving another example, small example, some additional examples today on permutation, and then we shall move into combinations. We will do number of problems from exercises 5A, 5B, 5C and also 5D of your study material. It contains number of extremely thought-provoking, interesting examples, and if you can solve all of them, including the ones in the additional question bank, which is given at the end of permutation combination chapter, then I think to a large extent you shall all be well prepared to face any question on permutation combination in the exam. And today I shall also be doing the problems which came from this chapter in the CA May MTP, that is the model test paper of May 2020. Okay, so I'm giving one example. There are 6 boxes and 3 balls. So 6 boxes and there are 3 balls. In how many ways can you put these 3 balls into the 6 boxes so that not more than one ball, so that not more than one ball will fall into a box, right? So we have 3 balls and we are having 6 boxes, right? And we have to put the ball into the boxes in such a way that I cannot put 2 balls in one box. In other words, I cannot put more than one ball in a box. I hope you have understood the problem. So in this case, if I have 3 balls and I have 6 boxes, the first ball, ball 1, in how many ways can I place it? I have 3 balls here and I have 6 boxes. Okay, so I am having 6 boxes, okay, and 3 balls. So we have to find out in how many ways we can drop this. So 1, 2, 3, 4, 5 and 6. Okay, so I'm having 6 boxes, fine, and we have 3 balls with us. So let us see the fundamental way, right? The balls I have here 1, 2 and 3. Okay, so 3 balls and 6 boxes. Now, just think, no need to memorize any formula. Just see the concept. 6 boxes, box number 1, 2, 3, 4, 5, 6. Right? I have got 3 balls. B1, B2, B3. Okay? And I have to put these balls into these boxes such that not more than one ball will go into one box. So for B1, ball number 1, okay, so for ball number 1, all the boxes are now empty. So ball 1, right, ball 1 can be placed in any of the 6 boxes. The boxes are empty. So it can be placed in how many ways? So I'm writing B1, B2, B3. And here I will write the number of ways in which they can be placed. So ball 1 can go into this box, box 3, box 4, box 5 or box 6. That means ball 1 can be placed in 6 ways. 6 boxes, 6 ways. 6 boxes, 6 ways. Now please assume that ball 1, I have blindly thrown the ball into a box. So covering my eyes, thrown the ball into a box. And ball 1 lands up in box number 4. So here we have ball 1. Okay? So ball 1 has gone here in box number 4. Now I am getting ready with the second ball, ball number 2. Okay, now since we already have got one ball in this box, box 4 is already having one ball. So as per the given question, I cannot put this ball number 2. Ball number 2 cannot be placed here. So I have 1, 2, 3, 4 and 5. 5 ways in which I can place ball number 2. So I will write here beside ball number 2, I write 5 ways. Now say, again by covering my eyes, I throw the ball randomly in whatever direction, in the direction of the boxes, but I don't know where it lands. And after opening my eyes, I find that ball 2 has landed in box number 1. So ball 2 is here. Okay. So now I have the last ball, the third ball, and the third ball, if you see, how many boxes are available now? Let's count. So 1, 2, 3 and 4. So we have 4 boxes which are available, and therefore I write 4. Friends, please note that here throwing the balls in 6 boxes, right? The way I have drawn the 6 boxes and the 3 balls, say ball number 3 say lands up in box 6, right? Now we have got 3 separate events. This is 3 events. Throwing of ball number 1, first event. Throwing of ball number 2, second event. And throwing of the third ball is the third event. Please note, these 3 actions, these 3 events are interlinked. They are related. Because if I throw one ball and ball 1 lands in box 4, I cannot use box 4 for throwing another ball. In other words, I cannot throw any other ball in box 4. I have to look for other boxes, but not box 4. That means these 3 events, throwing of ball number 1, throwing of ball number 2, and throwing of these 3 balls, ball number 1, 2 and 3, these are 3 separate events, but they are related to each other, they are linked with each other, and therefore, why, I hope you now understand, we apply the multiplication rule. So multiplication rule will be applied, and therefore the number of ways in which you can put these 3 balls in the 6 boxes will be 6 into 5 into 4. That is 120 ways. So this is the conceptual way. I hope you can now see clearly that we had 6 boxes, we are throwing 3 balls, and it is going to land up in one particular box, and the rule, the condition given in the problem is that if one ball goes into one box, I cannot throw another ball in the same box, so not more than 1 ball per box. That is the given condition in the problem, and we are using without using formula, just using logic, just using reasoning, just using our normal common sense, we arrive at 120. Now you have good knowledge of permutations. So ultimately, if I use permutations, I am trying to select 3 balls and selection of 3 balls, and I am having 6 boxes. So I think you will agree with me if I say that this is a case of permutation, and if I just write 6p3, let us see what this 6p3 will give us. So 6p3 is 6 factorial divided by 6 minus 3, that is 3 factorial. If you simplify 6p3, so 6 factorial is 6 into 5 into 4 into 3 into 2 into 1, and in the denominator we have 3 factorial, that is 3 into 2 into 1. So 3 and 3 cancels out, 2 and 2 cancels out, 1 and 1 cancels out. We are left with 6 into 5 into 4. That gives us again 6 into 5 into 4. That is 120. Right? I hope you will be remembering this example, and from this I hope you are now absolutely clear with the multiplication rule and the addition rule. Okay, so I rub it out, and now I take up many of the questions which are there in the exercises and which I kept it for today. In the last day we did number of problems. Now we do some more problems so that you are absolutely clear of this from any problem which comes on this chapter, and you are fully confident to face any sort of questions. I take up exercise 5A. Is how much? Please see the question. If NP4, so the permutation of n objects taken 4 at a time, NP4 is equal to 12 into NP2, then we need to find what is the value of n. Let us try to simplify this. As usual, like the other days, I request you to keep your pen and paper handy with you so that you can do the problem along with me, and that is the best way to learn maths. I'm sure you are doing it, and as your responses are coming every day, I'm really happy to see that all of us are learning, working hard, learning, and our confidence level is increasing. That is what is expected, and thanks to ICAI for this excellent platform by which we can connect with each other, right? So let's solve this problem. NP4. Now this is equal to n factorial divided by n minus 4 factorial, left hand side. So this is equal to 12 into NP2, that is n factorial by n minus 2 factorial, right? So this can be simplified. First of all, n and n cancels out. So we are getting 1 by n minus 4 factorial, but I will keep it as n minus 4, no change here. Right hand side we have 12 divided by factorial n minus 2 factorial. Now n minus 2 factorial, you know, is equal to n minus 2 factorial means n minus 2 into n minus 3 into n minus 4 and so on. So I can write this as n minus 2 into n minus 3 into factorial n minus 4, because n minus 4 factorial, it goes on till 3, 2, 1. Okay? I hope we have done it last day also. I hope you are able to understand this step. So n minus 2 factorial, I am writing it as n minus 2, n minus 3 factorial n minus 4. So from here, from both the sides, you can see I will cancel what is common on both the sides. N minus 4 is common. So factorial n minus 4 factorial is cancelled out from both the sides. So we are left with what? We are left with n minus 2 into n minus 3 equals, so cross multiplying, equals to 12. Right? I hope this is clear. N minus 2 into n minus 3 equals 12. This is, again you see, we go back to our knowledge of quadratic equation. We go back, it's a revision of equations also. That's why we did equation earlier, so that we can handle these type of situations. So we have n minus 2 into n minus 3 equals 12. So let us multiply and see what happens. Of course, we can use trial and error, but let us try and use our knowledge of equations and see whether we can solve this. N minus 2 into n minus 3 is n square minus 5n, n square minus 5n, 5 into n, plus 6. This is equal to 12. So I can write, I'm writing here now, so we can write n square minus 5n minus 6 equal to 0, because 12, if it comes on the left hand side, it will become minus 12. So it will be n square minus 5n plus 6 minus 12, that is n square minus 5n minus 6 equal to 0. So let us now use our knowledge of quadratic equations, splitting the middle term. You remember ax square plus bx plus c equal to 0. And we remember that the two roots alpha plus beta is equal to minus b by a and alpha beta equal to c by a. So using the same principles, we split the middle term and we get n square minus 6n plus n minus 6 equal to 0. So minus 6n plus n is minus 5n. So this is n into n minus 6. I am taking from this part, I am taking n common. Plus, I have n minus 6. So I am taking 1 common. It becomes n minus 6 equal to 0. So this gives us n minus 6 into n plus 1 equal to 0, which means n can be 6 or minus 1. Now the question is here, n is what? Permutations. One good thing is, in case of permutations, we don't have negative signs, right? We cannot say that, can you find out the permutation of minus 20 objects? No, not possible. Secondly, we don't have fractions. Thank God, thanking the Almighty. Oh, that there are no complications. We only deal with positive whole numbers. No imaginary numbers, right? No irrational numbers. Plain and simple, positive integers. No fractions. Thank God. So this is n equal to 6 or minus 1. But n cannot be minus 1 because it's a case of permutation. So n equal to 6. That is the answer. So this is number 9, a lovely problem given in the study material. I hope you are clear with this. We simplified the formula, then n minus 4 gets cancelled out. So we get the quadratic equation. We are solving n square minus 5n minus 6 gives 0. And we get, from here we are splitting the middle term. So we get n square minus 6n plus n minus 6. And from there n comes to 6. And we have rejected n equal to minus 1 because in case of permutations, we really cannot have minus anything which is negative, right? So I hope you have followed it. Now we carry on with number 10. So in this way, we will be solving number of problems today. And since we know the concept of permutations, combinations now will be very easy to understand. Okay, I am now taking up number 10. So let us take question number 10. Please open number 10, exercise 5A. The question is, if NP3 is to NP2 equal to 3:1, then what is the value of n? Right? So this is the question. If NP3 is to NP2, so it's like you have read about ratio and proportion, right? So I hope you have good knowledge. That was, I think, one of the first chapters which you must have done. And in case of ratio and proportion, you know this is very similar to a proportion. So A is to B equal to C is to D, right? So you see in mathematics, all the chapters are related, and ratio, proportion and indices builds up the foundation on which the other chapters would actually depend upon. So you need to be very strong on ratio, proportion and indices so that you are able to deal with any problems which can come from other chapters. So let's solve this. NP3 is to NP2 equal to 3:1. So we directly go to we'd have to split up. Now we'll try to expand NP3 and NP2. So this is n factorial n divided by factorial n minus 3. This sign, is actually division sign. Right. So what I can do is, let me write it like, that if A is to B equal to C is to D, right, then I can write A by B equal to C by D, right? So AD is equal to BC, like this. So what I do is, this is to NP2. So factorial n minus 2. This is equal to 3:1. That is 3 by 1. So now I divide factorial n by factorial n minus 3 factorial. So n factorial by n minus 3 factorial divided by n factorial by n minus 2 factorial. So now n minus 2 becomes the numerator. It goes up and this comes down. So into n minus 2 factorial by n factorial equal to 3 by 1, that is 3. So n factorial cancels out. We now have n minus 2 factorial in the numerator and n minus 3 factorial in the denominator, but you know that n minus 2 factorial actually means n minus 2 into n minus 3 into n minus 4 into so on. And this part, starting with n minus 3, this part is nothing but factorial n minus 3. So I can write this as n minus 2 into factorial n minus 3. n minus 2 into factorial n minus 3. So I'll break it up. In the numerator, I will put n minus 2 into factorial n minus 3. Okay? And in the denominator, we already have factor n minus 3 factorial. This is equal to 3. So this cancels with this. So you get n minus 2 equal to 3. If n minus 2 equal to 3, then n is equal to 3 plus 2. That is, n is equal to 5. Okay? So it's just a simple application of expanding each and every formula in NPR formula. NPR, you know, is factorial n divided by factorial n minus r. Just by applying the formula, and the rest is simple cancellation, and we reach n equal to 5. So this is problem 9 and 10 of our study material exercise number 5A. Now we proceed to page number 5.3. So we solve more problems and it improves your understanding, and I hope the concept becomes as clear as crystal. Okay, so page 5.3, example number 4. Okay, page 5.3 and example number 4. In fact, I had a request from Bhavadharini R of Tamil Nadu, who has requested me to take up this problem, and it is otherwise a very important problem also. This is, let me tell you, seems like a bit twisted, okay? But again, what is the fun if we don't do some tricky questions? Okay, the question is, if n plus 1 factorial is equal to 30 into n minus 1 factorial, then we have to find n equal to how much? Please note the question once again so that you can do along with me and practice. N plus 1 factorial is equal to 30 into n minus 1 factorial, then find n. Well, let us see what we can do. Looks a bit tricky and complicated, isn't it? Okay, so let's see. So n plus 1 factorial I can write as n plus 1 is equal to n plus 1 into n minus 1 factorial. See if you understand this step. N plus 1 factorial means what? N plus 1 into n plus 1 minus 1 into n plus 1 minus 2 into n plus 1 minus 3 and so on. Right? Please see here. But what is this part? This is n plus 1, fine. This is what? N plus 1 minus 1 means what? N. Or plus 1 minus 1 is cancelled. N plus 1 minus 2 is what? It is n minus 1. Plus 1 minus 2. N plus 1 minus 3 is what? It is n minus 2. And so on. Right? So this part, starting with n minus 1, this part, this particular block, I am marking it. This particular block, this block, n minus 1, n minus 2, n minus 3, this is what? This is nothing but n minus 1 factorial. So this part, n plus 1 factorial, actually means this is equal to n plus 1 into n minus 1 factorial, and I put this expression here. Okay, so I have written n plus 1 into n minus 1 factorial is equal to 30 into n minus 1 factorial. So from here you can see on left hand side we have n minus 1 factorial. You can see n minus 1 factorial, and here also n minus 1 factorial. So both the sides we cancel n minus 1 factorial, and therefore we are left with n plus 1 into n is equal to 30. n plus 1 into n equals 30. Let us, as usual, multiply and see. So this becomes n square plus n equal to 30. Here, again, friends, we come to a quadratic equation. You can see that slowly we are assuming the form of a quadratic equation, and we get n square plus n minus 30 equal to 0. N square plus n minus 30 equal to 0. Now we have to split the middle term plus n. Now how can I do it? Let me think. 6 into 5 gives me 30, and 6 minus 1 is 6 minus 6 into 5 gives me 30, and 6 minus 5 gives me 1. Oh, sounds great. So I'll use it and see what happens. So this is n square plus 6n minus 5n minus 30 equal to 0. Right? This is how we are split. Plus n we have expanded as plus 6n minus 5n. Okay? So what do we get? N square plus 6n. Let us take n common. So I am taking n common. You get n plus 6. From this part we take minus 5 common. So again you get n plus 6 equal to 0. So two expressions, n plus 6 into n minus 5 equal to 0. Same question again in front of you, dear friends. So we get two values of n from here. N is either minus 6 or n is equal to 5. Which one will you take? Which one? Can I take n equal to minus 6? No, because permutations cannot be negative. So I will take n equal to 5. So therefore the answer is n equal to 5. Right? So this is how we have broken it up, and I hope the process is clear and you have understood the thought and what is the approach of solving the problems. Right? That is why we do it through board works, to understand all the steps, the thoughts involved, the strategies, the formula which is used, and we also calculate. Because if you don't practice calculation, if you don't practice the equations in the exam, it will be a challenging task. Right? So the more we practice, the more perfect we become. Okay. Now we have question number 17, exercise 5A. Okay, I'm rubbing this part. I hope you have followed this. We are trying to analyze each and every problem, and I hope it's useful and meaningful for you. So I'm taking up exercise 5A, question number 17. Many of you have requested me to take this up. For example, Diksha Sen from Jaipur has requested me to take this up. Please see the question. Kindly open the study material. If you don't have it, please download the revised study material from ICAI.org. Go to the Board of Studies Knowledge Portal, BOS Knowledge Portal. You will be getting the study material. You will be getting the corrigendum, that is the corrections made. Plus, you will be getting the mock test paper of May 2020. Please download the study material in case you don't have a hard copy. Okay, the question is n articles. We want to arrange n articles such that two articles will never come together. Two articles will never come together. So this is seems to be tough, little tough, you know. So what to do with this? Now you will be getting several problems of this type. So we should be familiar to identify the type of problem where you will get this expression will never come together. So we have to form committees. Say out of 10 people, we need to form a committee of 7 so that Mr. A and Mrs. B will never come together. So this type of problems are there. So let's recognize what to do here. Now, let's first think. We break this up. Okay? Will never come together. first we find out the number of ways where two articles will always come together. So let's first find out the number of ways where the two articles will always come together. Okay, they will always come together. Okay, so let's do that first. Now, say there are n articles, right? So now what we do is, out of them two articles we bring out. Please follow the step. This is not a very easy one. It is tougher than the earlier problems, a wonderful problem in the study material. So from n articles we bring out 2. So now this part it becomes n minus 2. So from n we have brought out 1 and 2. So it becomes n minus 2. These two, let's call it article A and article B. These two are now clubbed as one. They will be treated as one article, because the question here is, we want to first find out number of ways where these two articles will always be together. They will always be together. Like, we say na Fevicol ka jod hai, tutega nahi, like that. So it's coming together. It is not going to be separated. It's just coming together. So same thing we do here, A and B. So we are clubbing A and B together into one group. So now this is taken as one. Okay, not as two objects but one. So now we can say that the total number of items here is, we have n minus 2 and we have 1. So we can write n minus 2 plus 1, that is n minus 1. Okay, now this n minus 1 objects can be arranged in how many ways? 4 objects can be arranged in 4 factorial ways. 10 objects can be arranged in 10 factorial ways. Therefore, n minus 1 objects can be arranged in n minus 1 factorial ways. I think this is clear, right? Now, out of these two objects, A, B, if you interchange, like for example, I have a black marker and red marker. Initially, we are trying to find out the number of ways where this red and black will be together. So it is now taken as 1, right? Instead of 2 separate, I club it together, 1. Fine? Now, the question is, these two can be clubbed together, fine. I am combining it here. I am just putting my hand around these two marker pens. But please see, from your side, you will see the right one towards your left and the black one towards your right. But now, if I rotate, it becomes black one towards your left and right marker towards your right. That means, two conditions are possible, AB or BA. That means A and B within themselves can be arranged in how many ways? 2 factorial ways. So this multiplied by 2 factorial ways. 2 factorial is how much? 2 into 1, that is 2. So this can be simplified as 2 into n minus 1 factorial. So please note, we have to find out the number of ways where the two articles will never come together. N articles are there. We have to find the number of ways in which two articles will never come together. What we have done so far is to find out the number of ways in which two articles will always come together. As if they are united by an invisible bond and you cannot separate them, they are together. And that is what we have found out. 2 into n minus 1 factorial. Okay, 2 multiplied by n minus 1 factorial. Now the question is, we started with n objects. In general, n objects can be arranged in how many ways? N objects can be arranged in how many ways? So, it can be arranged in n factorial ways. Out of the n factorial ways, there are how many cases when these two articles will always be together? How many cases are there? Will always be together. It is this. 2 into n minus 1 factorial. So if I tell you that you can arrange, say, n number of objects in 20 ways, out of which in 5 cases the 2 objects are coming together. Then in how many cases the objects are not coming together? 20 minus 5. So 20 number of cases, total number of cases 20, out of which there are 5 cases where A and B are coming together. So in how many ways, in how many cases A and B will not come together? They will be separated. How many cases? It will be 20 minus 5. Same thing here. Total number of cases is n factorial, out of which 2 into n minus 1 factorial cases where A and B will always be together. That means if you just find out the difference of these two, that difference will be the answer to the question, how many cases where these two articles will never be together. That means the answer is n factorial minus 2 into n minus 1 factorial. So the final answer is n factorial minus 2 into n minus 1 factorial. Right? This was, I think, a bit tricky, I'll say, but then if you understand the fundamental postulates and the fundamental principles of permutation as we discussed in detail last day and today, I think you will be able to understand the steps. It looks a little bit tricky, but it is not so. Once you understand the process, it becomes logical, and we have just used this technique of finding first in how many cases these two articles will always come together, and then we have subtracted it from the total number of cases, that is n factorial minus 2 into n minus 1 factorial. Okay, I rub it up and now I move on to number 12, exercise 5a, number 12. So let us take this question, exercise 5a, number 12. So one by one, most of your queries are getting solved. This question, especially a request has come from Sonal of Thane, who has requested me to take this up. The question is exercise number 5a and the question number is 12. Exercise 5a 12, your study material. So the question is 5PR is equal to 60. So R equal to how much? 5PR is 60. So R equal to how much? It's good that we are solving your queries as well as doing revision so that we have absolutely no problem on this chapter, right? 5PR equal to 60. We know the formula is NPR is equal to n factorial divided by n minus r factorial. So in this case it is 5 factorial divided by 5 minus r factorial, which is equal to 60. Fine? But 5 factorial means what? 5 into 4 into 3 into 2 into 1 divided by 5 minus r factorial. This is equal to 60. Now here the numerator is 5 into 4, 20 into 3, 60 into 2, 120. So I write 120 divided by 5 minus r factorial is 60. So from here, let's go up here. That means 62. Okay. So by cross multiplying this and this, cross multiplying, I get 5 minus r factorial gives me 2. Okay. So we get 5 minus r factorial equal to 2. Now I hope you can solve it. 5 minus r factorial is 2. Can I write in this way? 5 minus r factorial is equal to 2 into 1. 2 is nothing but 2 into 1. Which means 5 minus r factorial is equal to 2 factorial, because 2 into 1 means 2 factorial. So now 5 minus r factorial is equal to 2 factorial, which means 5 minus r is equal to 2. Therefore, if you transpose r to this side, it becomes r is equal to 5 minus 2, that is r is equal to 3. Please see the solution once again. Direct problem, 5PR equal to 60. So we have taken the formula of permutation, NPR equal to factorial n divided by n minus r factorial. So we have taken n is 5 here. We have taken 5 factorial divided by 5 minus r factorial equal to 60. We have now expanded 5 factorial, 5 into 4 into 3 into 2, we get 60 here. By simplifying it, we get 60 into 2 is 120, so we get 5 minus r equal to 2. 2 is nothing but 2 into 1. So 2 into 1, which means 5 minus r equal to 2 factorial, because 2 into 1 means 2 factorial. From there, we get 5 minus r equal to 2, which means r is equal to 3. I hope you have now arrived at this result and you are clear about the entire process. Okay. Now we move on to exercise 5b. Okay. 5b. B for Bravo. So 5b. We are moving to exercise 5b and the number is number 20. Please move to page 5.15. Okay, page 5.15. So page is 5.15, exercise number 5b, and let us take up number 20. Number 20. Okay, the question is, let us write the word mobile. You can see the question in front of you. The question is, in how many ways can the letters of the word mobile be arranged so that the consonants, the condition is consonants will occupy the odd place. The consonants will occupy odd place. How many ways can you arrange the letters of the word mobile where the consonants will occupy the odd place? Friends, you know about vowels and consonants. A, E, I, O, U are the 5 vowels in the English alphabet, and the rest of it, so 21 letters out of the 26 letters are consonants, right? Any letter which is not a vowel is a consonant. So here the condition is the consonants will be occupying the odd place. So let us write, let us draw, okay? So there are 6 letters, 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, and 6. Okay. So we have got 6 circles, and the idea is that the consonants will occupy the odd place. Now let us see which are the consonants here. So we have consonant, C is a consonant, N is a consonant, right? Sorry, mobile, M is a consonant here, B is a consonant, L is a consonant. So we are having O, I and E as the vowels here, and we are having the consonants are M, B and L. So underlining M, B and L. The three consonants are here, M, B and L, and O, I and E are the 3 vowels. Now question is, we have to place it in the odd place, right? The odd. So odd place is, odd, even, odd, even, odd, even. So odd, underlining odd, and odd. So ODD, odd place. Okay, so we have how many vowels here? So vowels we are having 1, 2, 3, and consonant C we are having 3. So very simple, we have to place 3 consonants in the odd place. How many odd places do we get here? 1, 2 and 3. So 3 consonants in 3 odd places. 1, 2 and 3. So it's a case of 3P3. So this is the way in which we'll be placing first the consonants into the odd positions, into the odd places. Once we do it, we shall be left with the 3 vowels, and for them we have 1, that is the even places, even 1, even 2 and even 3. So again we have 3 places. So we multiply by 3P3 again, because this 3, once again please focus, this 3P3, this 3 is for the odd place, 1, 2 and 3. This 3 which you see here is for the consonants. I am slashing consonants. The second one is this 3 is for the even, that is 1, 2 and 1, 2 and 3. This one. Even. So the even is 1, 2 and 3. So this number which you see is for the even positions 1, 2 and 3. And this number 3 is for the vowels which are going to occupy 1, 2 and 3. And 3 vowels, 3 places. So the number of arrangement will be 3p3 again. Since this is a case, you can see we are applying multiplication formula because we are multiplying 3p3 by 3p3. Why? Because this is a case of multiplication formula, because there are events which are linked with each other. 2 events. Event number 1, placing the consonants in the odd positions. So odd, odd, odd. Event number 1. Or you can call it, it's my first work. Work number 1. The second work is placing the vowels O, I and E in the even positions, that is 1, 2 and 3. So 2 pieces of work, 2 separate set of work which are interlinked, which are related to each other. Therefore, we use multiplication formula, and so 3p3 into 3p3. Let's, if you just simplify this, 3p3 is how much? 3 factorial by 3 minus 3, that is 0 factorial, that is, it becomes 6 by 0 factorial is 1, so 6. So 3p3 into 3p3 is 6 into 6, that is 36 ways. So the answer is 36 ways, right? So this is example number 5b, and the question was number 20, right? So I rub this out, and I hope now it's clear how, because this type of problems you will be facing many such problems in the exercises given in the additional question bank, and questions like this can be expected in the exam also. Therefore, we need to be very clear about the technique of solving this type of problems. Hence, I took this up. Okay, so rubbing this up, and we now move to the next question. I request you to move to page number 5.8, and let's do the next problem quickly. So the question is 5.8. So I quickly go to 5.8, page number 5.8, and the question number is 16. Okay, and exercise 5A. Exercise is 5A. Exercise 5A, number 16. Exercise 5A, number 16, page 5.8. Okay, the question is 10 exam papers are arranged in a way, 10 exam papers are arranged in a way such that the best paper and the worst paper will never come together. They never come together. Okay. So this questions, there was a request from Prachi Gupta from Panchkula, and I'm taking this up as a very important question. 10 exam papers, best and worst paper will never come together. Never come together. It will never come together. So this is a very similar exercise to what I did little while back when I took up that n number of objects, and we found out the formula when 2 objects will never come together. If the formula was, if you remember, n factorial minus 2 into n minus 1 factorial. This I did couple of minutes back. I hope you remember it. So in this case, if you see here, n is 10 exam papers. So directly let's put the formula. Now that we know it, we have proved that formula. Now let us directly use the formula. So here n is 10. So I write 10 factorial, right? So I write 10 factorial minus 2 into n minus 1. That is 10 minus 1. That is 9 factorial. So 10 factorial minus 2 into 9 factorial. Now this gives me what? This gives me 10 factorial is what? I can write 10 into 9 factorial. Because 10 factorial is what? 10 into 9 into 8 into 7 into 6 and so on. So I can write 10 into 9 factorial, right? So I have written that 10 factorial is 10 into 9 factorial minus we have 2 into 9 factorial. From this, you take 9 factorial common. So, a minus b, you have 9 factorial common. So, 9 factorial comes out, and in bracket we have 10 minus 2. 10 minus 2. That is 9 factorial into 8. Or you can write in this way, 8 multiplied by 9 factorial. Okay, this is the answer. So this was, now that you know this formula and I proved it, how to use this formula and how we are arriving at n factorial minus 2 into n minus 1 factorial. So directly we put in the values and here comes the solution to the problem. Okay friends, we proceed now to number 11. Let me see. Okay, I'll take this first. Page 5.3. Okay. So we are solving a number of problems and I'm sure you are getting more comfort, confidence, and you are able to get that level of, sheer positivity inside you that yes, any problem comes, I can solve it. Right. This is page 5.3 and let us take this up. Page 5.3, example 3. This is a solved example and I had a request from two persons, Muskan from Patna and Neelam Solanki, who requested me to take this up. So let us see how to do this problem. This is, it's a problem which has been solved in the study material, but I'll just explain it to you. Okay, the problem is 1 by 9 factorial plus 1 by 10 factorial is equal to x by 11 factorial. So we have to find x. So x equal to how much? Please see the problem once again. 1 by 9 factorial plus 1 by 10 factorial is equal to x by 11 factorial. Okay. So what we do here is we just simplify the given expression and we break it up. So let us try and break it up. So we are having here on the left hand side, we are having, let's put it in this way, 1 by 9 factorial plus 1 by 10 factorial is what? 10 into 9 factorial. Okay. So here we have 9 factorial, here we have 10 into 9 factorial. This is equal to x divided by 11 factorial means 11 into 10 into 9 factorial. 11 into 10 into 9 factorial. Please see. So we now take the LCM of this side. So 9 factorial and 10 into 9 factorial. So I'll take 10 into 9 factorial here. So it becomes 9 factorial. It becomes, will go 10 times plus this is 1. And here we get x divided by 11 into 10 into 9 factorial. So this becomes 11. 11 by 10 into 9 factorial. This is equal to x divided by 11 into 10 into 9 factorial. Okay. So let me just check this factorial 9. Sorry. 10, 9 factorial. Right. So now let us proceed here. So till now let us see what we have done. 1 by 9 factorial plus 1 by 10 factorial is equal to x by 11 factorial. We have taken the LCM. What we have done is we have expanded 10 factorial. 10 factorial is equal to 10 into 9 factorial. And I have kept 9 factorial as it is. Taking the LCM, 10 plus 1 equal to 11 divided by 10 into 9 factorial. This side as it is, I have only expanded 11 factorial. And 11 factorial is 11 into 10 into 9 factorial. So 11 into 10 into 9 factorial. So this is what we have achieved. Now we proceed. We are proceeding here. So now let us just cross multiply and see what we are getting. So x, right? So we will try to see what we get. So from here x is equal to this expression will go to this side. So it is 11 by 10 into 9 factorial multiplied by 11 into 10 into 9 factorial. So this expression goes up, right? So this expression has come to the numerator, which means 10 cancels with 10, 9 factorial cancels with 9 factorial. We are getting x is equal to 11 into 11. 11 into 11 is 121. So x is equal to 121. That is the solution. Please see, it naturally follows. I hope Muskan and Neelam, both of you are now clear. I have taken your query and solved it out. I hope now it is clear to you. And simple case of addition and just breaking up, splitting up 10 factorial into 10 into 9 factorial first and 11 factorial, break it up into 11 into 10 into 9 factorial. Rest will follow smoothly and naturally. No twist, no turns, just go straight. Okay, just a straight line. Right, fine. Example 6 and page is 5.5. Okay, this is 6 into NP3. 6 into NP3 is equal to 7 into n minus 1 P3. We have to find the value of n. N equal to how much? Okay. Please see the question once again. 6 into NP3 is equal to 7 into n minus 1 P3. Okay. So let's try and break it up. This is equal to 6 into NP3 is factorial n minus 3 factorial. This is equal to 7 into n minus 1 P3, that is n minus 1 factorial, divided by n minus 1 minus 3, that is n minus 4 factorial. Fine. We simplify further. On the left hand side we are having 6 into n factorial. So n factorial can be broken down as n into n minus 1 factorial. N into n minus 1 factorial. So I am using the same formula, n into n minus 1 factorial. Denominator we are having n minus 3 factorial. This can again be broken into n minus 3 into n minus 4 factorial. So this will be n minus 3 into n minus 4 factorial. Right hand side we are having 7 into n minus 1 factorial. Denominator n minus 4 factorial. So if you see the common parts, we deduct, we eliminate them, we cancel them out. So n minus 1 cancels out. N minus 4 cancels out. So we are getting, the expression is cross multiplying again. So it's cross multiplying. We are getting 6 into 1. Okay. 6n. 6n into 1 is equal to 7 into n minus 3. 7 into n minus 3. This is the equation. So this is equal to 6n is equal to 7n minus 21, which means transposing n, we are getting n is equal to 21. So this is the answer. Right? So please see the problem once again. 6 into NP3 equals 7 into n minus 1 P3. We have broken up n into n minus 1 factorial. N minus 3 factorial we are breaking up into n minus 3 into n minus 4 factorial. Automatically these are getting cancelled out. You can see n minus 1 cancelling with n minus 1 factorial. N minus 4 factorial cancelling with n minus 4 factorial. Now it becomes a linear equation like a straight line. You see a ruler, straight line. So a straight line, and therefore n comes to 21. Simple solution. The problem I think is now clear, and the way I worked it out, I'm sure you are getting more clarity. Fine. Rounding this up and now moving on to the next question. I'll take the last one possible. Okay. Okay, this, let me see if I can take it up, or we'll take it later. Okay, let's move on to, once again, another one. And this is something which I did last day, just quickly explaining once again. I had explained a question last day, and that was, if there are seven elements, A, B, C, D, E, F and G. So 1, 2, 3, 4, 5, 6, 7 elements, and if you have to create permutations, that is arrangements out of them, such that the last character must always be A. So circles 1, 2, 3, 4, 5, 6 and 7. The last letter will always be A. Okay. So how many ways can you do it? So you have A, B, C, D, E, F, G. So you are having 7 elements and you have got 7 circles here. But the condition is the last circle will be occupied by A. That is the last letter of all the words, of all the arrangements. Last letter will be A. How many ways can you do it? In fact, I had explained this last day. However, one of our friend Khushi Singla from Haryana requested me to explain it again. Good that we are able to revise, because many of you might have had, maybe you didn't understand or could not completely follow. Now I'm sure you'll be able to follow. I'm explaining once again. So here you are having 6 plus 1, 7 circles, and the last circle will be occupied by A only. That means what? The condition is given. That means we are now having, if you leave aside A, so A is already taken. So you have 1, 2, 3, 4, 5, 6. 6 letters. And how many circles do you have? 1, 2, 3, 4, 5, 6. So you have 6 circles, 6 letters. Arranging 6 letters into 6 circles, right? Or 6 boxes, whatever you call it. So it is 6p6. This is equal to 6 factorial by 6 minus 6 factorial. That is 6 into 5 into 4 into 3 into 2 into 1 divided by 6 minus 6 factorial is 0, and we know 0 factorial is 1. So this is 6 into 5 into 4 into 3 into 2 into 1, that is 30 into 4, 120 into 3, 360 into 2, 720. So the answer is 720. Okay? I hope, Khushi, you are now clear, and many other friends, I'm sure you are now clear. Okay. Now we proceed into combinations. Okay, last one. This is an interesting one. Let me take this one. This is interesting. Additional question. Not possibly, it's not there in the exercise. It's an additional question. Let's see. Now, the question is like this. You are creating a password with 4 digits. Okay? A password with 4 digits. Okay? You cannot repeat a number. You cannot repeat a number. How many possible arrangements can be there? No repetition. No repetition allowed. Okay? You cannot repeat any number, but you have 4 digits password, right? Many times what happens is we say you are born in the year, 2002, right? So you give your password 2002. Many people give their email ID. Right, say somebody is Hari Shankar, so hari.shankar2002 at gmail.com, something like this. So many people use this year of birth as a password. Should not be done. But in this case, a question of password, how to make sure how many passwords you can create with 4 digits, no digit can be repeated. So dear friends, there are 4 digits, 1, 2, 3 and 4. Okay, so let us go first to the units place. Okay, you know units U, then tens T, then hundreds and then thousands. Okay, 4 digits. For the units place, you have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0. Right, you can take any of them. Okay, so how many digits do you have? 10 digits. So units place 10 ways. Any digit can be taken, 10 digits. Moving to the tens place, no repetition allowed. So 10 numbers you selected for the first digit, out of them 1 has been taken. So now for the tens place you have 9. 9 possible numbers. Okay, we proceed to hundreds. One more is gone. So 1 and 1 gone. So it becomes 8. 9 minus 1 becomes 8. Similarly, for the thousandth place, you have 7. So you are getting, this is a case of multiplication rule, dear friends. Please see that there are 4 events. I'm now sure many of you who raised the question that, sir, how to understand whether the question involves application of multiplication rule or the addition rule. You can see I'm giving example after example, number of examples on multiplication rule, and from this you can understand how multiplication rule can be used, when to use, when to apply. What are the signs? So the signs here is 4 digits, 4 dependent. They are not isolated, they depend on each other because no repetition allowed. Which means if I take 7 here, I cannot take 7 here. Repetition is not allowed. So it becomes 7 into 8 into 9 into 10. So we multiply. So this is 7 8s are 56. So if you just calculate 7 8s are 56 into 9. So 56 into 9, 4 and 5, 45 and 50, 504. So I think this is 5040. Okay. So we get the total number of possible outcomes in which you can create a password with 4 digits such that no number is repeated, no repetition is allowed. It comes to 5040 possible outcomes. Right. We proceed now and quickly move into combinations. Then, time permitting, we will take some more examples. Okay. Now, I'll ask you a very simple example. I request you to now just relax and be alert. Relaxation doesn't mean, going to sleep or drooping down, but just relax. We're not going to do any calculation for the next few minutes, and let's understand, right? I might write something here, but you don't have to write, just understand. Now, you see, in case of combination, permutation, we saw that the order A, B, C, C, B, A, 1, 2, 3, 3, 2, 1, it matters. Okay? The order is important, the order is relevant. This is in case of permutation. But in case of combination, the order is not relevant. Right? So, whether you are asking ABC or CBA or BAC or BCA doesn't make a difference. In case of permutation, AB and BA, these are two separate outcomes. But in case of, this is in case of permutation. In case of combination, AB and BA is counted as 1. Right? Now, if I ask you that my locker, right? My locker in my bank, okay? My bank locker has a combination, right? Now, the combination is 23, 5 and 17. 23, 5 and 17. It's a combination, I would say it's an arrangement of 3 numbers, 23, 5 and 17. That means once I type 2, 3, then pause, 5 and then 1, 7. The locker opens up. Just turning the key and I can have access to my bank locker. Right? So this is an arrangement. So I can call it an arrangement. Now my question to you, dear friends, is this sequence of numbers, is it important? That means instead of 23, 5, 17, if I just change the order, if I write 17, 5 and 23, will my locker open? Question mark. Yes or no? What do you think? Will my locker open? Digits are same. I just forgot the order. Just forgot. Oh, it can be, we don't write passwords everywhere. Not in your mobile phones, not in your tabs. Everything is in the memory. Memory is getting overcrowded. So many things to remember. So maybe I typed in the wrong number. I just give the wrong arrangement. Will the locker open? No. So that means it is indirectly a case of permutation where the order is important. Okay. So like I talked about, say, your pin credit card, debit card, PIN. So say your PIN is 1014. Right, this is the correct PIN. But while quickly, withdrawing money, you have given 1041. Digits are the same, but the order is different. You will not be able to withdraw money and the error message will come. Wrong password, wrong PIN. So these are examples of permutation and not combination, right? This is the basic difference between permutation and combination. Right, now I give you another example as we slowly enter into combinations, right? Say for example, 3 letters P, E and N. Okay, 3 letters are there, P, E and N. How many 2-letter words can you create? How many 2-letter words can you create out of them? So you can create P-E, P-N, E-N, E-P, N-P, N-E, so and so. 1, 2, 3, 4, 5, 6. Yeah, we have got total 6. So these P-E, P-N, E-N, E-P, N-P, N-E, these are all P-E, E-P. So it is interchanged. P-N, N-P, E-N, N-E, interchanged. So this and this are interchanged. P-N and N-P are interchanged. And P-E and E-P are interchanged. But we have got 6 separate arrangements. Just see, quickly let's see how the total thing will change the moment. This is a case of permutation because the order is important. P, E and EP are taken as 2 different sets. PN and NP are counted as 2 different, not as 1, 2 different. Similarly, EN and NE are counted as 2, not as 1. But if I ask you that PEN stands for, say, P for Pokemon, E for Elsa, and N for Nobita. Okay, I think all are very famous, world famous characters. So these 3, and if I ask you that can you create from these 3 people, can you create groups of 2? So now we have P Pokemon, E Elsa and N Nobita. If I ask you, now forget about this P-E-N, this part, forget. Now we focus on this part. Pokemon, Elsa, Nobita, if I ask you to create groups of 2 people out of these 3. So what will you do? You can take, I'm writing Pokemon and Elsa. You can take Elsa and Nobita. You can take Pokemon and Nobita. Can you take any other? I mean, can I write P and E here means Pokemon and Elsa. Do you think if I write Elsa and Pokemon, this and this, will they be different? If I say you and your parents, and then I say your parents and you, are they different or is it the same group? Please think for a while. I hope you have understood the question. So far as P-E-N are concerned, yes. If you think of them as letters, yes. P-E and E-P are different. But the moment I make them into people and I ask you to create a group of 2 people from these 3 characters, we are assuming they are living characters, right? So the moment we do it, we find Pokemon and Elsa and Pokemon are the same. So in this case, if I write Elsa and Nobita and here I write Nobita and Elsa, it won't be a different set, it's the same set. Similarly, Pokemon and Nobita, and if I write Nobita and Pokemon. So this right side does not matter anymore. Pokemon and Elsa and Pokemon are the same. Elsa and Nobita and Elsa are the same. Pokemon and Nobita and Pokemon are the same. Which means this is the concept of combinations, where the order does not matter. Your parents and you, this is one order. Parents are first, then you. If I say you and your parents, you are coming first, then parents. It means the same. This is the concept of combination. And this is where it's different from permutation. In case of permutation, we saw 6 possible conditions. So PE, PN, EN, EP, NE and MP. But here, the moment I made P for Pokemon, E for Elsa and N for Nobita, you find that we have only three. Three groups can be formed: Pokemon and Elsa, or Elsa and Pokemon, Elsa and Nobita, or Nobita and Elsa, and Pokemon and Nobita, or Nobita and Pokemon. So we have three and not six. Okay? So this is what is combination. Therefore, we will move now into what is combinations therefore. So you can understand that combinations means the same thing, arrangement of objects into groups where the order is not relevant. We saw here Pokemon and Elsa, Elsa and Pokemon. The order is not. So we have taken only three. So for permutation it will be 6 in this example, but for combination it is only 3. Permutation it is 6, NPR. So it is P6, so NP6. NP6 will give you how much? NPR. So if you take this, 6P6. So 6 objects, 6P6 is how much? 6 factorial. Right. So if you take this in this way, here we were trying to find out, sorry, we have taken 2 letters. So it will be 2 letters out of 6. So it will be 6P2, sorry, 6P2. 6 people are there and you are, 3 people are there, sorry, 3 people are there, PEN, and you are taking 2 of them each. So 3P2 is 3 divided by 3 minus 2, that is 1. And 3 factorial is 6. So we got 6 examples here, 6. PE, PN, EN, EP, NE and NP. But here, the situation is totally different. We only have 3 possible arrangements of the 3 characters Pokemon, Elsa and Nobita. Therefore, dear friends, in case of combinations, the order does not matter. So PE and EP will remain the same. AB and BA will be counted as 1 and not 2. So please note, this is the basic difference between what is permutation and what is combination. Now in case of combination, let's quickly see the formula. We have, in case of permutation it was NPR, in case of combination it is NCR. The formula is, in case of permutation it was what? N into N minus R. This was the case of permutation. In case of combination it is N, factorial N minus R, same as permutation. Now the only difference is there is one more object here and that is R factorial. R factorial will come in the denominator. So you can see it is almost the same excepting for this R, which is the basic difference. Okay, this R is the only difference, and the concept is, in case of combinations, the arrangement, the sequence, the order will not matter, but in case of permutation it will matter. Okay, so this is what is meant by permutations and the difference with combinations. So now let us do some small examples of combinations. The formula you can note: factorial N factorial divided by N minus R factorial multiplied by R factorial. So in the denominator we are having R factorial as well as N minus R factorial. Let's take few examples. 8C5. So we are doing combination of 8 objects taken 5 at a time, 8C5. So 8C5 is 8 factorial in the numerator divided by R, that is 5 factorial, multiplied by 8 minus 5, that is 3 factorial. So 8 factorial divided by 5 factorial into 3 factorial, this will give me how much? Let's do 8 into 7 into 6 into 5 into 4 into 3 into 2. And down below we have 5 into 4 into 3 into 2 into 1 multiplied by 3 factorial, 3 into 2 into 1. So 5, 4, 3, 2, 1 and 5, 4, 3, 2, 1 cancels out. You have 3 into 2, 6 and 6 cancels out. I think this becomes 56. 7 into 8, 56. So this is 8C5. Right? I hope thing is clear. We saw the example of PEN, and we saw it was 6 example. It came to 6 cases because PEN are 3, and from there we were selecting 2. So 3P2 we did, it came to 6, right? But the moment I gave the name Pokemon, P for Pokemon, E for Elsa, N for Nobita, it became 3. And I said it was a case of combination. So what I did was 3C3. 3C3 came to 3. Let us see whether it is correct or not. So let's work out 3C3. 3C3. This will be equal to what? 3P2 is 6. But now, sorry, we take 3C2. Sorry, 3C2. 3C2 came to 3 because we are taking 3 characters, Elsa, Pokemon and Nobita, and we are taking 2 at a time, 3C2. Let's see whether it's 3 or not. So 3C2 is 3 factorial 3 divided by factorial 2 into 3 minus 2. So you are getting 3 factorial means 3 into 2 into 1. Denominator you are getting 2 factorial 2 into 1, and you are getting 3 minus 2, that is 1 factorial, which is 1. So 2 and 2 cancels out, this becomes 3. So in case of permutation, PEN we took 3 letters, it was 3P2, selecting 2 out of 3, we got 6. But in case of combinations, the moment I called it them Pokemon, Elsa and Nobita, it became 3C2. 3C2, and 3C2 is equal to 3. Right. Now we will take another example. Let's rub it up. We took one example 8C5. Now we take the other example, and that is 8C8. Okay, let us do 8C8 and see what happens. 8C8. 8C8. 8C8 is how much? 8 factorial in the numerator. Denominator it will be NCR. So R factorial, R is 8. So 8 factorial into 8 minus 8. Because the formula is N factorial divided by R factorial into N minus R. So this comes out to 8 factorial. Denominator 8 and this is 0. So 8 and 8 cancels out, and you know that factorial 0 means, we are clear about it, factorial 0 means 1. So this is 1. Okay. The next one, let's take an example. In how many ways you have 10 friends? Okay, 10 friends are there. In how many ways can you choose 5 out of them for dinner? You want to invite them for dinner. You have 10 friends. You want to invite 5 of them for dinner. So in how many ways can you do it? So the question, dear friends, is, say you have 5 friends, say 10 friends are there. Let's call them A, B, C, D, F, G, H, I, J. Okay? So you have 10 friends, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A to J. And say you are selecting any 5 of them. Let's take randomly. I take B, D, F, G and J. So let me circle them up. B, D, F, G and J. So the order is B, D, F, G and J. But if I tell you that instead of B, D, F, G and J, if I change the order, say it is J, D, B, F, G. Please see. B, D, F, G, J. Now it is J, D, B, F, G. So phonetically, Bravo, Delta, Foxtrot, Golf and Juliet. And we have in this case Juliet, Delta, Bravo, Foxtrot, Golf. Okay? Will they be same? Well, if you are talking about friends, whether you invite Ram, Shyam and Hari, or whether you invite Hari, Shyam and Ram, it's the same. The order will not matter. you are getting the same friends, right? So the order will not matter. That means this is a case of permutation? No, it's a case of combination. So we apply straight away the simple formula NCR. So here N is equal to 10, R is equal to 5, your 5 friends. So we apply the formula NCR, that is 10CR, and R is 5, so 10C5, that means 10 factorial divided by 10 minus 5 factorial multiplied by 5 factorial. Let's work it out here. So 10 factorial, let's work out. 10 into 9 into 8 into 7 into 6 into 5 factorial, and in the denominator we are having 5 factorial into 5 factorial. So this 5 factorial gone. So in the denominator we now have 5 factorial. This is 5 into 4 into 3 into 2 into 1. So let's multiply this. 5 into 2 times, 4 again 2 times, 3 and 2 cancels out 6. So we are having 7, 2, 9 and 2. So 7 into 2 into 9 into 2. That is 7 nines are 56 into 2. 56 into 2 is, let's just check. 2, 9, no, 9 is the 2927. 2927. 2927. So 7 nines are 63 into 2. 126 into 2. So this is 252. Yes, 252. 7 into 9 into 2 into 2. Okay. So we are having 10 into 9 into 8 into 7 into 6 into factorial 5. We are deducting, we are cancelling factorial 5 from numerator and denominator. So we are getting 7 into 2 into 9 into 2, which gives you 252 ways are there, right, of inviting any 5 friends out of 10 friends in at your house for dinner. Okay. So this is, I think, clear, and we are using the same formula. And now we take some more analysis. So a simple example, say Mary is trying to join a club, a library, a book club, right? So small example, let's do. So Mary wants to join a book club and she has a choice of 10 books, right? So she is joining a book club. Mary is joining a book club and she has a choice of 10 books per month. She will take at most 2 books. How many different pairs of books she can take from this book club? Very simple, directly NCR, right? Because selection of books. Now whether you have a geography book and a history book, geography and history, and if I say history and geography, I have changed the order, but it's same. You have 4 subjects in your exam. Whether I say accounts, mathematics and statistics, law and economics. And if I turn it around and say economics, law, accounts and mathematics, will it mean anything different? No, the 2 are the same. So this is a case of combination, not permutation. So it will be NCR, and therefore here the condition is 10C2. Let's see what 10C2 is. 10 factorial divided by 10 minus 2 factorial, that is 8 factorial multiplied by 2 factorial. So this, if you break it up, it comes to 10 is 10 into 9 into 8 factorial divided by 2 factorial and 8 factorial. 8 and 8 cancels out. So 2, 5, this comes to 45. So she can have 45 different pairs of books every month. Okay. Now we'll take up some questions from the study material, and we will take the first one, page 5.16, page 5.16, and the question example number is 2. 5.16 and the example number is 2. Please go to page 5.16, kindly refer to page 5.16, page 5.16, example number 2. So the question is, let S be the collection of 8 points. So this is a plane, okay, a plane. Sorry, just do this thing. We are drawing a plane, 1, 2, 3 and 4. It's a plane. And there are how many points? 8 points are there in the plane. 1, 2, 3, 4, 5, 6. Put 6 here, sorry, 6, 7 and say 8. There are 8 points. So I'll circle the points. I'll circle the points 1, 2, 3, 4, 5, 6, 7 and 8. And the plane you know is a horizontal plane. It is say H and K. HK, right? It's a plane and on which we have kept points. So the question is, how many triangles can be drawn using these 8 points? How many triangles can be drawn using these 8 points? And 3 points, any 3 points are not collinear. You know what is called collinear points. No collinear points. Collinear points means 1, 2 and 3. The 3 points are on the same straight line. So here none of them are on the 3 straight. Even this point which you see is not on the same straight line. The straight line is this. This is not on the same straight line. Okay, different. So what will happen? Here n is equal to 8. 8 points are there. Point number 1, 2, 3, 4, 5, 6, 7 and 8. 8 points are there. N is 8. To draw a triangle, in order, the question is how many triangles can you draw? So to draw a triangle, you need how many points? You need 3 points. So here R is 3. So the question is NCR, that is 8C3. NCR, 8C3. Let's see how many choices we will get. 8C3 means factorial 8 divided by 8 minus 3, that is 5 factorial into 3 factorial. So this means 8 into 7 into 6 into 5 factorial divided by 5 factorial into 3 factorial. 3 factorial is 6. So 5 and 5 cancels out. 6 and 6 cancels out. You have 7 into 8. That is 56. This is the answer. 56. Which means that you can draw 56 triangles keeping these 8 points on the plane. Right? The plane is HK. You have got these 8 points. If you connect randomly any 3 points, you will be able to get 56 triangles using the formula of combinations NCR. So it's not a case of permutation, it's a case of combination. Okay, next one we'll take up. Example 3, page 5.16. This is example 2. Now we go to example 3. Okay, please see the problem. Example 3, page 5.16. Example 3, page 5.16. Okay, example number 3. A committee is to be formed out of 3 persons out of 12. 12 people are there. You have to, out of 12, you have to create a committee. Committee of 3 persons. Simple. Like Pokemon, Elsa and Nobita. PEN. If I say Nobita, Pokemon and Elsa. NPE. The order does not matter. So here also the order will not matter. So it is not a case of permutation, but it's a case of combination. So we will use NCR formula. N is 12 and R is 3. So it is 12C3. That is 12 factorial divided by 12 minus 3. 9 factorial into 3 factorial. So this gives me, if you break it up, it comes to 12 into 11 into 10 into factorial 9. In the denominator, you have factorial 9 into factorial 3. And factorial 3 gives you 6. Factorial 9 cancels. 6 into 2, 12. So you have 2 into 11 into 10. 2 into 11 into 10 is 22 into 10, 220. So the answer is 220. So you can have 220 ways of forming committee of 3 persons out of 12 members or 12 persons, right? So this was 5.16 example 3. Now I'll take up, okay, let me take this one. Okay. Example number 4. Okay, let's take example 4. This is a very interesting one and some working out has to be done here. So the example is a committee. So this is example 4, the same, we are continuing with the same thing. A committee of 7 members is to be chosen from 6 chartered accountants. So 7 members, you have to choose from 6 chartered accountants, 4 are economists and 5 are cost accountants. I am writing a CMA, cost and management accountant, CMA. In how many ways can this be done if in the committee there must be at least 1 member from each group and at least 3 chartered accountants. So there needs to be at least 3 chartered accountants and 1 member from each group. So you have 7 members and you have to create a committee of 7 members and you have to choose them from 6 chartered accountants, 4 economists and 5 cost accountants, such that you have at least 3 chartered accountants and there must be 1 member at least from each of the groups. Okay, so let's see the various ways of selecting the group. So we draw a table. Now, what can be the possible ways of selecting? Okay, so we'll write the method. This column is for the CAs. This column is for the economists. This one is for the cost and management accountants. Okay, fine. So method 1, the first one, you need to create 7. So you can have 3 CAs, 2 economists and 2 cost accountants. In the second case, you can have 4 chartered accountants, 4 CAs, 2 economists and 1 cost and management accountant. You have to take at least 1. Please note, the condition is at least 1. Method 3, you can take 4 chartered accountants, 1 economist and 2 cost and management accountant. Please note, 3 plus 2 plus 2 is 7, 4 plus 2 plus 1 is 7, 4 plus 1 plus 2 is also 7. The fourth method, you can take 5 chartered accountants, 1 each from economist and 1 from CMA, 1 cost and management accountant. Fifth method can be 3 chartered accountants, 3 economists and 1 cost accountant, and finally you have the last way where you can take 3 chartered accountants, because 3 is the minimum. You can see 1 will be an economist and 3 will be CMA, cost and management accountant. Now it's a long calculation. So these are the 6 options possible. If you want to form a committee of 7 members from 6 chartered accountants, 4 economists and 5 cost accountants, these are the 6 possible ways. Now, how do you calculate now? It's a long chain of calculation, but I'll show you the method. So for method 1, I'm writing here 1, 2, 3, 4, 5 and 6. So all this 6 is coming here. So the calculation will be like this. This one we will do here. This one we will do here. The third one we will do here. The fourth one we are going to do here. Fifth one is here and sixth is here. Okay. The first one, 3 CAs, 2 economists and 2 cost accountants. You have how many CAs? 6 CA. So the calculation is 6 CA3. 6 CA and 3 CA. Okay. Multiplied by multiplication rule. Multiplied by economists, you have 4 economists. So 4C2 into 5 cost accountants 5, here cost accountants 2. So it is 5C2. We have to find the form, the calculation. We have to do the calculation. Method 2. Method number 2 is we have 4 CAs. So it will become 6C4. 6C4 into 4C2. Because you have 4 economists, you are taking 2 out of them. 4C2 into 5 cost accountants, here you have 1. So 5C1, again value. Number 3, 4 CAs, you have 6 here. So 6C4, 6C4. You have one number, we are doing number 1, 2, 3. Third one, you have 1 economist. You have 4 here. So into 4C1 multiplied by, you have 2 cost accountants here. You have 5 CMAs here. So 5C2. This is the third one. We go to the fourth one, 511. So 6C5 into 5C1. 6C5 into, 4C1. 6C5, we are doing this one, 6C5 into 4C1. 4C1 into 5 cost accountants, here you have 1. So 5C1 into 5C1. Again, the value has to be brought out. Fifth case, 331. You have 6 chartered accountants, here you are taking 3. So 6C3 into 4 economists, you are taking 3 out of them. So it is 4C3 into 5 cost accountants, you are taking 1. So 5C1. And finally the last one, 313. So the last one is 313. Combination is 3 chartered accountants, 1 economist and 3 cost accountants. So if you calculate this one, it will be 6 and 3. So 6C3 into 4C1 into 5C3. Long calculation, if you simplify, you are getting, the first one is 1200, the second one is 450, then you have 600, then you have 120, then you have 400, and then you have 800. So the total works out to 3570. So this one is a bit complicated. That's why I solved it out to show you what can be the maximum level of questions which might be coming, right? Now we move on to 2 of the simple formula of combinations, and we will solve other problems also. So I hope this is clear. Here we had to form a committee of 7 consisting of the given number of persons included 6 chartered accountants, 4 economists and 5 cost accountants. So we created all possibilities by which we can achieve this committee of 7. So 322, 421, 412, 511, 331 and 313. We wrote down all possible combinations. We added up to get the total amount, the total number of combinations which is possible. Okay. So this is a classic example of combination. Now we will see 2 small properties of combination. So I'll just wrap this up and please note the next 2 examples of the properties of combinations. So NCR formula, let us see some further formulas. Only 2 very simple. First is NCR is equal to, it is equal to N into R factorial into N minus R. But this is also equal to NC N minus R. Okay. That means 7C5 NCR is equal to 7, that is NC into N minus R, that is 2. So 7C5 is equal to 7C2. Similarly, 4C1 is equal to 4C3. Okay. So this is the first formula. And the second formula, please note, is N plus 1 CR is equal to NCR plus NCR minus 1. So please note these 2 formula. so that you are able to use it. Plus, we know that NCN equal to 1, NC0 is equal to 1. So please note these two formula. These are given in the study material and these are the properties of combination. So NCR, like 7C5 I have taken, is equal to NCN minus R, that is 7 minus 5, 2. Here N is 4, R is 1. NCR is equal to NCR minus 1. 4 minus 1 is 3. Right. Okay, so now we go to some more problems. Okay, I am taking one of them from the model test paper and important for your exams. Let me take this one. I am just rubbing this part. So this two formula, please keep a note of it. This you need to remember, N plus 1 CR is equal to NCR plus NCR minus 1. Okay. Now we proceed to see some more examples and we will solve more problems. We'll take some really complicated ones and time wise we are absolutely fine. Just crossing 4 o'clock and we can push further because today is the last day of permutation combinations and therefore we need to cover some more problems. Okay. So we will we will push a little further. Okay. The question is, company is having 6 departmental heads and it has 6 departmental heads and it wants to promote 2 of them. It wants to promote. So promotion time, it wants to promote 2 of them. How many ways can you do it? Direct question, simple combination. So here N is 6 and R is 2. So you want to promote 2 out of 6. You want to promote 2 persons out of 6 persons. Therefore, it's a question of combinations, not permutation. Combination, NCR, and here N is 6 and R is 2. So NCR will be 6C2. That is 6 factorial divided by 6 minus 2, 4 factorial into 2 factorial. So you get 5 into 6 and here you get 4 is cancelled out. You get 2 here. So I think it comes to 15 ways. 15 ways. So there are 15 ways in which you can promote 2 persons out of 6 persons when there are 6 departmental heads. So this is a simple one. Now I take one more from the MTP. So this was from the test paper, the model test paper. I take one more from the model test paper. So you can see, dear friends, I am covering problems from the study material, from the solved examples, from additional questions also, and also from the MTP. Now this question is from the MTP, model test paper. The question is 10 PR. 10 PR is equal to 604800. Fine. And 10 CR is equal to 120. So you have to find the value of R. R is how much? So friends, you can see it is a case of both permutation and combination. It's a combination. You can see a combo. It's a combo offer given to you. Permutation and combination together. So how do we solve this? Right. It's a simple, looks simple, but some calculations are there. Some steps are necessary to solve this. So let's get going and try to solve this. So friends, we know that just now we saw a formula. If you see, just writing here, NPR is equal to factorial n into n minus r. I think this is clear. We know. NCR is what? Factorial n into factorial n minus r into factorial r. R factorial. So I can write, basically from this relation I can write that NCR is equal to NPR divided by factorial r. Just see. NCR is nothing but NPR divided by factorial r. From this formula. You have the same thing. You have factorial n here, factorial n here. You have n minus r here, you have n minus r here. The only extra, the only additional item is r factorial. So I can easily write NCR is equal to NPR divided by factorial r. So in this example, what we will do is we will write 10 PR. 10 PR, the value is given 604800. So I directly write 604800 is equal to NCR, that is 10 CR. 10 CR is how much? 10 CR is 120, and I write, so the idea is NPR. If I write NCR is equal to NPR by factorial R, right? That means what? That means NPR is equal to NCR into R factorial, cross multiplication. So this is NCR into factorial R, cross multiplication. So here we have NPR. NPR is 604800. 604800. That is this. So it will be equal to what? It will be equal to 10 CR. 10 CR into R factorial. And we know 10 CR is 120. So I can write this is equal to 120 into R factorial. So 604800 is equal to 120 into R factorial, which means R factorial is how much? 604800 divided by 120. Please see. Once again. 10 PR 604800. 10 CR is 120. We have to find the value of R. So what we have seen, the formula, the basic formula is NPR is factorial n by n minus R factorial. NCR is n factorial divided by n minus R factorial into R factorial. So the relation is NCR is equal to NPR by R factorial. So on transposing, you get this NPR gives you, what is this NPR? This NPR is NCR into R factorial. So cross multiplication. So putting the value here, NPR is 10 PR. 10 PR is this 604800. I put the value here. Multiplied by 10 CR on the right hand side. It is equal to 10 CR multiplied by R factorial. 10 CR is 120. So 120 into R factorial. So the equation is 604800 is equal to 120 into R factorial. So R factorial becomes 604800 divided by 120, and this comes out to 125,040. 5040. So you get R factorial is equal to 5040. How to find R? So if you have R factorial is 5040. So now you have to go on multiplying to see what is R. So let us use a calculator and see. 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. Let's see. 1 2s are 2. 2 3s are 6. 6 4s are 24. 24 into 5 is 120. Into 6 is 720. 720 into 7. 720 into 7. 0. 7 2s are 14. 1 5 0. So R comes to 7. So R is 7. So R factorial is 5040. By multiplying, we reach 5040 when R is 7. Right? So R is 7. This is not very easy as well as not very tough, midway, but a lovely problem, and it is from the MTP, management or the model test papers. Okay. Right. Now we come to another question from the model test paper, and this is based on a formula of combinations. So you can see the beauty of this subject. Mathematics is such a beautiful subject, and I think the icing on the cake, the 2-3 chapters, time value of money, permutation combination, and of course calculus, the beauty of mathematics. Right. So let us look at this question. A man has 5 friends. Okay, man has 5 friends. In how many ways can he invite one or more friends for dinner, to dinner? You have 5 friends. In how many ways can you invite one or more people for dinner? That's the question. So first situation, let's draw the situations. Sorry, draw the situations. So we'll draw the table. 1, 2, and 3. And this. So let us draw the table here. First, serial number, and we draw the situation. Okay. Now you can call how many friends? First situation is you can call 1 friend. 2 is 2 friends. Situation 3 is 3 friends. Situation 4, 4 friends. Situation 5 can be 5 friends. Okay. So this is the number of friends you are inviting, and this is the formula to be used. And this is the result. So for 1 friend we will write, for 2 friends we will write, for 3 friends we will write, 4 friends will compute, and 5 friends will also compute. 1 friend if you want to invite, only 1 friend. You have 5 friends, you want to invite 1. How many ways can you do it? NCR. Okay? So NCR. So N is 5, but R equal to 1. If you want to invite 1 friend. So the formula is 5C1. So I write 5C1. If you find out 5C1 gives you, the value is 5. Value is 5. Fine. If you want to invite 2 friends, you want to invite 2 friends for dinner. You have 5 friends. So here R becomes 2. So it is 5C2. If you find out the value of 5C2, it comes to 10. 3 friends. So R becomes 3. 5C3 is the formula. 5C3, you will see it also becomes equal to 10. Please see the formula NCR we saw. NCR is equal to NCN minus R. So 5C2 is also equal to 5C3. NCR is equal to NCN minus R. Here N minus R is 5 minus 2, 3. Okay? So same formula. 4 friends if you want to invite. 5C4. But 5C4 is equal to 5C1. NCR is equal to NCN minus R. 5C1 we have already done, so it is 5. And if you want to invite all 5 friends, in how many ways can you do it? I have 5 friends, I want to invite all 5. Well, basically I can do it in only one way. Inviting all my 5 friends for dinner. So 5C5 is 1. So let me add up. 5 plus 10, 15. Plus 10, 25. Plus 5, 30. Plus 1, 31. So the answer is, I can invite, a person can invite 1 or more friends out of his 5 friends in 31 ways. Now here there is a formula for this type of questions, because this is something we have done analytically. For larger numbers you need to remember the formula. The formula is very simple, 2 to the power n minus 1. This is the formula. That means if you want to take combination of n different things, taking some or all of the n things. So here it is, we had 5 friends, we are taking some of them or all of them. Some of the friends, 1 friend, 2 friends, 3 friends, or all of them, 5 friends. So in that case the formula is 2 into n to the power n minus 1. So in this case, here n is 5. So if you put this formula, please note this formula. For using this formula, if you put n equal to 5 here, you get 2 to the power 5 minus 1. 2 to the power 5 minus 1, 2 to the power 5 minus 1 is how much? 2 to the power 5 is how much? 2 into 2, 4 into 2, 8. Into 2, 16, into 2 is 32. So 32 minus 1. This is also 31. Here we also got 31. So please remember this formula as well, which is going to be very useful for you in solving problems. Fine. Now we take up some more questions here, and I'll take up a question from page 5.24. Now we go into all types of problems. So both permutations and combinations as well. I hope you're enjoying the session, learning as well as noting down. It is not entirely fun, little bit of hard work, fun, and learning something new and getting the confidence out of it, right? So it's all work and no play makes Jack a dull boy, all play and no work. So we are playing also a little bit, having fun, at the same time learning together, right? So I'll move on to the next one. I hope this is clear how we achieved it, and this formula is important. Very simple formula, but important. Okay. We now move on to 5.24, page number 5.24, requesting you to move to page 5.24. Page number 5.24, first example, 5.24 example 1. How many permutations are possible from the letter of the word calculus? Okay, now last day we did a problem very similar to this where I took the word management and we wanted to find out how many permutations are possible. So this is a case of permutation P. The question clearly says how many permutations are possible from the letters of the word calculus. Now, if you see in calculus, how many letters are there? 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there. Fine. Out of 8 letters, let us see how many are common. So C we are having 2. C is 2. L again 2. Okay. Then we are having U again is 2. Right? And the other 2 letters are A and S. So we are having C, 2 C's, 2 L's and 2 U's. Right? This is how calculus is made. And now the permutation will be, you know, n things. If there are n things, the permutation formula is factorial n. N objects can be arranged in factorial n factorial ways. N objects in n factorial. So 8 letters altogether can be arranged in 8 factorial, but out of them, out of the letters, 2 are C. These 2 letters can be arranged in 2 factorial. So this will go in the denominator. So C is gone. Again we have 2 letters L, 2L which are common, same letters. But they can be arranged in 2 different ways. So again it goes into division. 2. And we have 2 common letters U. So this again comes up here. So this is equal to 8 factorial divided by 2 factorial into 2 factorial into 2 factorial. So let us see what this brings up. 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 2 into 2 into 2. 2 into 2 into 2 because factorial 2 factorial is 2. So 2 and 2 cancels out. This 2 cancels with 2 here. This 2 with 3 here. So we have 3 into 2, 6. 6 into 5 is 30. 30 into 3 is 90. 90 into 7. 90 into 7 is 630. 630 into 8 is 5040. So the arrangement can be done in 5040 ways. I hope it is clear. And same thing we took last day. We took the word management. Principle is same. Total number of letters will come up here. If there are 10 letters, 10 factorial, and then you find out the common letters and they will go here. Right? Fine. I will take one more question on this. Okay. Okay. Now I will take some questions from 5C. Example 5C. Exercise 5C, and this will be different type of questions. Okay. I am first doing exercise 5C number 12. Please turn to page to exercise 5C of the study material number 12. The question is the number of straight lines obtained by joining 16 points on a plane. Right? How many straight line can you obtain by joining 16 points on a plane? So it's a plane sheet, right? A plane sheet. And there are 16 points. How many straight lines can you obtain? Now here we can easily understand n is 16, and to draw a straight line, how many points do you need? Like we did a problem on triangle, we need 3 points to draw a triangle. For a straight line we need 2. So R is 2. How many straight lines can you draw? It is very simple, selecting 2 out of 16. How many combinations can be done? So NCR, that is in this case 16C2. 16C2 works out to 16 factorial divided by 16 minus 2, 14 factorial into 2 factorial. So you get 16 into 15 divided by 2 to 8. So it comes to 120. 120 lines can be drawn. So we can draw 120 lines. So this was example number 12 and exercise 5C number 12. Of course, it had multiple choice question, but the answer is 120. Right. Now this is a classic, interesting one. Number 14. Let's go to number 14. Right. So I'll take up, I'm rubbing this. This is direct application. Let's go to number 14 now. Okay. Number 14. Okay. Please see the question. The question is, every 2 persons are shaking hands with each other. So shaking hands, how do you do? Hello. Right, shaking hands. In a party, of course, now it is unthinkable. You cannot shake hands. You just do this and maintain social distance. But this problem was prepared before this horrible phase of the pandemic started. So shaking hands was possible. Now, of course, we create long distance. Anyway, so every 2 persons are shaking hands with each other in a party, and the total number of handshakes is 66. So some guests are there. Okay. So person comes up to shake hands. Right. So person comes up to shake hands, and again a shaking of hands. Fine. So shaking of hands, great. Okay. So question is very social, very good, important, you know. Okay. So shaking hands, great, great gesture. But then the question is, first of all, this is not possible now. But then how many? There are 66 handshakes. Beautiful question. Hats off to our Board of Studies experts who have framed, who have prepared the study material and prepared these questions. Lovely questions. Okay. So now a person is shaking hands. Very good. And the question is, 66 handshakes have happened. But our question is, how many guests were there? Lovely question. MCQ, but one of the best I found. So here you see 66 handshakes. We don't know the number of guests. But you need, for 2 people to shake hands, you need 2 hands. My hand I extend, somebody else. So one thing is certain, this has to do something with NCR, right? Because it's not a permutation. If, say I have a friend, say Amit. Amit comes forward. Whether Arijit goes to shake hands first, Arijit shaking hands with Amit, or Amit shaking hands with Arijit is the same. Whether I shake hands with you or you come and shake hands with me, the order is the same. Please note. So it's not a permutation. It's a combination. It's a case of combination, not permutation. Right? So it's pure combination. So here, to shake hands, you need how many persons? You need 2 hands. So R is 2. Right? And the number of handshakes is 66. So we have to find N. The number of guests. Because if there are 20 guests and every 2 hands are selected, then you can find out ultimately how many handshakes. So here it's a classic question. You have to find N. N we don't know, but we know that number of handshakes is 66 and R is 2. So let's put this formula here. NC2 is equal to 66, which means, please see, NC2 means what? N factorial divided by n minus 2 into 2 factorial is 66. Okay, so you have nc2 and n factorial divided by n minus 2 factorial into 2 gives you 66. But n factorial can be written as what? N into n minus 1 into n minus 2 factorial divided by, here you have n minus 2 factorial into factorial 2. This gives you 66. So n minus 2 cancels out. Now you have the equation, you have n into n minus 1. N into n minus 1 is equal to 66 into factorial 2. You have factorial 2 here, 2 factorial. 2 factorial is 2. 66 into 2 gives you 132. Right? So we get ultimately again and again a quadratic equation. So you have n square minus n. If you multiply, you get n square minus n is equal to 132. So let me just complete the solution here on this side and let us understand. So 66 handshakes we have analyzed and we have seen that now it comes to 132. N square minus n is 132. So n square minus n minus 132 is 0. N square minus n is 132. So n square minus n minus 132 is 0. This means again we have to split the middle term. Now how do we split? Again that alpha plus beta concept of quadratic equation, right? So 132 is, we know, is 12 into 11, right? That is 132. So let's split it like this. N square minus 12n plus n minus 132 equal to 0. So taking n common from here, you get n into n minus 12 plus you take 1 common, n square plus 12n plus 11n. Yeah, this is 11n, sorry. This is 11n minus 12n plus 11n minus 132. So n into n minus 12 from the first term plus you have 11n minus 132. 11n minus 132, you take 11 common, so you have n minus 12. This is equal to 0. So what you get is n minus 12 into n plus 11 is equal to 0. Which means n is equal to either 12 or n is equal to minus 11. Again the question, n here means the number of guests. N means the number of guests. Now can you have negative guests? Negative guests, no. So you cannot have minus, you cannot have negative number of guests. So therefore n cannot be equal to minus 11. So therefore n has to be equal to 12. Okay, so this is how we prove or we compute this classic problem on shaking hands. And I think you have seen how we have arrived at this solution, right? Good to see such beautiful problems. Okay, now we go to number 18. Same exercise, number 18 quickly. We will solve another couple of questions before we close. And I hope you are getting that confidence of handling all types of problem. Number 18, exercise 5C. Okay, 8 points are marked on the circumference of a circle. So a circle is taken and 8 points are marked. So 1, 2, 3, 4, 5, 6, 7 and 8. Okay, circle center is O. Okay, so 8 points are marked. How many chords can be, how many chords can be made? How many chords can you draw by joining these points? Friends, you know in a circle, this is the circumference, this is the diameter, right? This is the circumference, this is the diameter. OA is the radius and say this is A dash. A dash is the diameter and chord is any 2 points on the line. So this is a chord, this is a chord, say HK is a chord, XY is a chord. Right, and we can say that diameter is the biggest chord. You can say like that. But here you have to make sure that there are 8 points and you have to draw chords. Drawing a chord means means you need 2 points. You are given 8 points. So 8 points. 8 points are given. Right? So what you need to do is you have to draw chords. So here it's an application of NCR and N is equal to 8. 8 points are there. So 1, 2, 3, 4, 5, 6, 7 and 8. 8 points are there. You have to draw chords. You need a straight line. Chord is a straight line, so you need 2 points to draw a chord. So therefore R is 2. So you have to find out NCR, that is 8C2. That comes out to factorial 8 divided by 6 factorial into 2 factorial, that is 7 into 8 by 2, that is 28. The answer is 28. Okay, so you can have 28 chords by joining these lines. So by joining these lines, like this is a chord, this is a chord, sorry, this is a chord, this is a chord, this can be a chord, this can be a chord, this is a chord. Like this, if you join, this will be another chord. So if you join, it will become 28 such chords can be drawn using these lines. Fine. Now I go to a classic one and number 20. We will take another 15 minutes. 4:45 will wind up. Target time. Just be with me and let us complete another few problems so that we can wind up. I'll take few queries at the end and I'll just wind up. So I think you are following, finding it interesting, and also we are having occasional fun, and I hope it is not that heavy. This chapter is a light chapter, and I hope we are able to connect. Even through the virtual mode, we are all connected. Okay, I'm taking example 20 now. Please see example exercise 5C, and the question number is 20. So this is 500 C 92 is equal to 499 C 92 plus N C 91. This is a very simple one, not that tough. Now, we saw two formula of combinations. I'm writing it here for refreshing your memory. Okay, we just did it today. Okay, so I'll just write once more. So we did, one formula was NCR equal to NC N minus R. This you saw. The other one was N plus 1 CR is equal to NCR plus NCR minus 1. Okay, this was the second formula, and this formula we shall apply here in this case. So please see, NCR, okay, is equal to, if I say N plus 1, if I write N as 499, N plus 1 becomes 500. So this becomes 500, that is N plus 1 CR, and R is 92. So you can see the formula. This becomes N plus 1 CR. N plus 1 is 500, 500. R is 92. R is 92. So it becomes N plus 1 CR is equal to, on the right hand side you get N is 499. 499. So I write N C. R is 92. NCR plus. Here you have N, which you have to find out N. C 91. 91 is what? R is 92. So it is R minus 1. The same formula. Right? So you can easily understand that this N has to be equal to 499. So N is 499 in this case. So direct formula, it's an application of direct formula. This direct formula is here. Direct formula. No change. Just if you see that this is how you develop your, your observation. So you can easily see 500, 499. Difference is 1. 92, 92, 91. So it is of the form. The given equation is of the form. You have to identify this. The given equation is of the form N plus 1 CR is equal to NCR. N plus 1 CR is equal to NCR plus NCR minus 1. Right? So you have NCR plus NCR minus 1. Once you put in the values, you can easily see that N has to be equal to 499. So this is what we have got. This is example 20. Now we go to some really interesting ones and rubbing this formula based. So we are doing so many numericals and we are solving many of the questions. Okay. Okay, now I go to two quick questions. Okay. Exercise 5C, number 21. Okay. So exercise 5C, number 21. Fine. Please see the question. The Supreme Court, the Honorable Supreme Court has given 6-3 decision upholding a lower court. The Supreme Court has given a 6-3 decision, okay, upholding a lower court. In how many ways it can give a majority decision? In how many ways it can give a majority decision to reverse the order? To reverse the order. You know how Supreme Court operates. You have lower court, you have the Honorable High Court, then you have Supreme Court. So in this case, High Court had given some order which Supreme Court has agreed, and they have passed a decision of 6-3. That means 6 people have voted in favor and 3 people voted against. So it's a question of 6/3. 6 people voted in favor, 3 voted against. Right? So who will do the voting? In Supreme Court, who will do the voting? Common man? No. The judges will do. So there are 6 plus 3, 9 judges. Okay? 9 judges, out of them 6 gave in favor and 3 opposed. 3 gave a verdict or 3 gave an opinion against. So you have 6/3. That's how the judges operate. That's how the Honorable Supreme Court operates. Majority decision. Now in how many cases? The question is tough. This question is a tricky one. In how many cases can there be where the Honorable Supreme Court can reverse the order? Again by a majority decision. Now if you think of a majority, majority means what? We always say 60-40 majority, 70-30 majority, 80-20 majority, 90-10 majority, 90 people in favor, 10 against. So there's a majority. 55-45, yes, 55 people voting for, 45 people voting against. It's a majority. 55 will win over 45. So here again majority. Let us see what can be the possible situations and then we will find out the answer to this question. So first we draw a table here as usual. We draw the situations and here we do, so I write the situation. Please do this with me. This is a tough one, 21. Situation, we write the formula and then we will do the computation. Okay, the value. Okay, first situation can be, so there are, you see there are how many judges? There are, we are having 9 judges. Okay, so you are having 9 judges, right? Total 9 judges. If you talk about the question of complete, you can say majority decision, then the combinations can be 5-4. That means 5 judges giving in favor, 4 judges against. It can also be a 6-3. 6 judges in favor, 3 against. It can be 7-2. 7 judges in favor, 2 judges against. It can be 8-1. 8 judges in favor, 1 judge opposing. And there can be 9-0. 9 judges in favor and nobody against. So in these cases, this will lead to a majority decision. And please see that in all these cases, the sum total is 9. 5 and 4 is 9. 6 and 3 is 9. 7 and 2 is 9. 8 and 1 is 9. 9 plus 0 is 9. Okay. Now, if you have to select 5 judges from the given 9 judges, first situation, the formula will be 9C5. Okay. If you want to select 6 judges out of 9, so you have 9C6. Second one. 7 judges out of 9, you have 9C7. 8 judges out of 9, you have 9C8. and 9 judges out of 9, you have 9C9. If you compute the values here, you get 9C5. 9C5 will work out to 9 factorial by 5 factorial and 4 factorial. So this is 6 into 7 into 8 into 9 by 4 into 3 into 2. So you have 4, 3, 2. So 14 and 9, 126. So this becomes 9C5 is 126. 9C6, if you work out, you will get 84. 9C7, if you work out, you get 36. 9C8 will be 9 and 9C9 will be 1. So this is now a case of addition. So this is an addition. You can see same work, right? Same calculations, same table. Now we add up. So this is the addition formula. So plus, 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 plus. So 126 plus 84 plus 36 plus 9 plus 1, you get 256. So 256 in 256 ways, the Honorable Supreme Court can reverse the order of a lower court with a majority decision. This is a classic problem given in the numerical part of our exercise 5C, and one of the toughest. I hope now it's clear. 6 by 3 means 6 plus 3, 9 judges. Then we found out the situation by which you can provide a majority decision, and then we broke it up and we calculated the values. So here we have 256 cases. Okay, now I'm moving to exercise 5D. Okay, we are left with another 10-15 minutes max to max, and we will have to complete few problems. Okay, so I move to exercise 5D, page 5.29. Page 5.29, exercise 5D, and I go to number 8. Number 8. The question is, the word commerce. How many arrangements can you create out of the word commerce? Okay, commerce. So how many arrangements can you create? Please note the question. Okay, so now in the word commerce, how many letters do you have? 1, 2, 3, 4, 5, 6, 7, 8. Fine. So step number 1, I write the number of letters. Okay, 8 letters. Fine. Now we see how many letters are repeating. So if you see, we are having C here and C here. So 2 C's. Fine. We are having commerce, M and M. So 2 M. And we are having E here and E here. So 2 E as well. So now the formula, we have seen the formula is, first is 8 factorial in the numerator, but we have certain common letters which are repeating, and therefore these will come in the denominator. So 2 factorial 2, because 2C can be arranged among themselves in 2 factorial ways. Similarly, 2M can be arranged in 2 factorial ways, and E, 2 E's can be arranged again in 2 factorial ways. So this, if you just work out, you will find this is 8 into 7 into 6 into 5 into 4 into 3 into 2. And in the denominator you have 2 into 2 into 2. This 2 cancels with this 2 and this 2 with 4. So you have 3 into 5 into 6. So 15 into 6 is 90 into 7. 90 into 7 is 630 into 8. I think 630 into 8 is again 5040. So you have 5040. Right? So this is again an interesting question. Okay. Now proceeding to number exercise 5D. We are taking number 19. Question number 19. 5D number 19. Okay, let's take number 19 now. 5D. So I have solved number of questions from exercise 5B. 5A last day I did. I'm doing 5D today. So let's take exercise number 5D, and the question is number 19. The question is 5 letters are written and there are 5 letter boxes, right? The number of ways in which the letters can be dropped into the boxes. Okay, similar problem we did today. So there are 5 letter box. Okay, there's a 5 letter box. So these are the letter boxes. You know you will see in the post offices. So 5 letters, there are 5 letter boxes like this, and you are writing a letter, okay, and this has to be posted. So there are 5 letter boxes. So same question. Let us draw the letter boxes quickly and then we will understand. Okay, so 3, and then we have the 4th one, and then here we have the 5th letter box. Okay, 5 letter boxes, and we have 5 letters also. So 5 letters, 3 letters, 4 letter, and 5 letters. Okay, now the first letter, letter 1, L1, L2, L3, L4, L5, and the boxes are B1. Okay, let's make it in blue. So B1, B2, B3, B4, and B5. So the first letter can go, the question is, every letter, the number of ways the letters can be dropped into the boxes, so that you have at least one letter. So first letter can go into 5 in 5 boxes. So we write 5 into. Second letter can go in 4 boxes because there should be at least one letter in each box, right? So you have 5 into 4. Then you have the third letter can be kept in 3 ways. Okay, so the 4th one can be in 2 letter boxes and the last one in 1. So this was similar to the question we did earlier today on that ball and placing the balls in boxes. Same thing here, letters into the boxes, letter box. So in this way, we are putting the 5 letters into the 5 letter boxes, and the technique is multiplication again, because these are interdependent and events. There are 5 events putting 5 letters in 5 letter boxes, but they are dependent on each other. They have an interrelation, and therefore we apply the multiplication rule. So 5 into 4 into 3 into 2 into 1, that is 120 ways, right? So this is how we solve exercise example number 19, 5.29. Okay, now some final questions. First one I take is an additional question, which is an MTP question. It came in one of the earlier model test papers. So the question is that there is a voicemail. Okay, there is a voicemail, and a voicemail system has a password like this. Okay, a password or a voicemail. The password is one letter. So this part will be a letter, A, B, C, D, anything, any letter. And then this will be a digit, D, a digit and digit. So there will be 3 digits. How many? But the question is, the 3 digit, it should be less than 600. The 3 digits here should be less than 600. How many different voicemail passwords are possible if all the digits are allowed? So first will be a letter, then will be a digit, 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 but these 3 digits should be less than 600. Okay, so beautiful question. Let's see how to solve this. First point to be noted is, this is a letter. Now, how many letters are there in the English alphabet? You have 26. So this place can be occupied in 26 ways, because there are 26 letters. Now, the question is, the first digit, whatever you write here, these 3 digits should be less than 600. So this particular digit which you will place here, your choices are 0, 1, 2, 3, 4, 5. You cannot keep 6, because if you keep 6 here, it will become more than 600. Right? So you have 1, 2, 3, 4, 5, 6. You have 6 options. So I write, this was 26, I write 6 here. Second digit. The third, this one, the second digit now. First digit is over, second digit. Second digit can be any number. Right? So you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So 10 numbers. So you can have any of them, 10. So you have 0, 2, 9, 10. Similarly, the last one can also have 10 digits. Right? There may be repetitions also in this case. Right? So same number can be chosen multiple times, but you can see the first digit you can take out of 0, 1, 2, 3, 4, 5. You cannot take 6 onwards. 6 onwards you cannot take. If you take 6 here, then it will become a 3-digit number more than 600. So you have, the options are, again this is a case of multiplication because we are having interdependent, interlinked events. And there are 4 events. First event is the letter. Second event is digit number 1. Third event is digit number 2. And the fourth event is digit number 3. So if you multiply, the total number of cases will be 26 into 6 into 10 into 10. This will be equal to 15,600. Okay. So this was a classic example once again. Now we go to the last MTP questions. That is MTP 2020. May 2020. Very important questions for your exam. And I'll be solving the questions which have come. We have another 10 minutes. I'll request you to be complete at around 5. So you can see we are working non-stop. I request you to push with me. And I know you are tired, but requesting you to again push forward because no pain, no gain. Right? CAMTP May 2020. Very, very important question. The question is, please see the question if you have the MTP, then how many number of ways? This is called intelligent question, and this is why I always request you to do number of problems. At the same time, I always request you to make sure that you are alert and read the question paper very carefully. Each and every word in the question paper is important. There can be twist anywhere. It's a professional exam and it's nothing but survival of the fittest. The best will pass. So make sure you put in that effort to see and to not just to see but to observe as well, and make sure you read between the lines. Let's see the question. The question seems to be a very harmless question. Computer. You have to write the word computer. The question is the number of ways in which the letters of the word computer can be rearranged. The options given: 40,320, option B 40,319, option C 40,318, option D none. 90% of us, maybe, I don't know, but guess is 90%. 90% will see the question and will say, oh wow, yes, I know. Oh yes, computer. Okay, so sir taught me in the class, virtual class. Oh, 8 letters. So 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there. So it is simply 8 factorial. Then denominator. Do we have any letters which are repeating? C, no. No, C, no, O, O. Fine. Then 8 factorial. 8 factorial, if you calculate, it is coming to, let's calculate. 8 into 7 into 6 into 5 into 4 into 3 into 2. 4 3s are 12, 2s are 24, 5s are 120, 6 are 126 are 720 into 7, 5040 into 8. 5040 into 8 is 8 zeros are 0, 8 4s are 32, 2, 3, 5 8s are 40. 40,320, option is there. Oh, this is the right answer. Yes, I have done it. Yes. No. It is the wrong answer. You will be wondering, what is sir doing? It is the wrong answer. Because the question is, I have written clearly, rearranged. Okay. So, if it was only arranged, then okay. But rearranged means this is already one arrangement done. So, how many other arrangements can you do? Excluding this. So, rearrange. So, the answer is not this, but this minus 1. That means this will be the answer. 40,319. So please quickly, while reading the question fast, make sure that you understand each and every point. That is why I am taking MTP May 2020 questions. Okay, so 90% of us will quickly do this and quickly go here and click option number A, and we come back home and yeah, oh yes, confident. I'll do well. I have picked the right answer. But sorry, you have to be very careful, right? Okay, the next one which I'm doing is, this is a classic lovely question which has come in the CAMTP, May 2020. Okay, let me wrap this up. I hope you have understood where to be careful. That's why I had to write the entire question along with the options. Now this is a beautiful question. Hats off to our question setters who are setting questions for the exam. I can tell you, as a faculty of mathematics for you, I can just tell you that setting question paper is a very tough job, believe me. Because you have to stay within the curriculum. The question should be an original question. The question should be intelligent question. It cannot be very easy. It cannot be very tough. At the same time, it has to be a question which will test the knowledge plus the observation. You saw the difference between arrange and rearrange. This is what computer. So question setting is tough. So I salute those experts, our senior, geniuses, I will say, who really set the question paper and give us these type of questions. Really, hats off to them. I now take up MTP question number 2. CAMTP question number 2. Let's see the question. 5 persons are sitting in a round table. Fine, round table. And 5 persons are sitting. Very good. Oh, I have A, let's B, C, and D, and E. Fine. Now the question is, they are sitting in such a way that the tallest person is always on the right hand side of the shortest person. So there is a tallest person. Let us do one thing, and there is a short person. So let me do one thing. Instead of A and B, I make it short S and T. So the question is, the tallest person, the tallest guy is always on the right hand side of the shortest guy. Okay? So the tallest guy is always on the right hand side, or if I'm the shortest guy, I'm S, I'm sitting in a circle, a table, right? So wherever I'm sitting, whether I'm sitting here, here, the tallest guy is on my immediate right. So if this is a table, right? I'm sitting here, I'm the shortest guy, the tallest guy, I look up to him like this, the tallest guy is here, always on my right hand side. Lovely question. It is going to test many of our, whatever knowledge we have in permutation, it's going to test each and every part. Hats off to the question. So, options are given, of course, 6, the options are 6, 8, 24 or none of the above. Okay, now let's see how to solve this. Okay, lovely question. And this is what I say, professional questions in a professional exam, meant for all of you who are becoming professionals. Okay, now, first thing is that I discussed in the last session that if you have n, a circular permutation, right, we discussed. N people in a row, if they stand in a row, how many ways can you arrange them? Factorial n. Fine. In a row, it's fine. But the moment it's a circle, n people can be arranged in n minus 1 factorial. So it becomes factorial n minus 1. First point to be noted. Right? Now here, if you see, 5 people are sitting. 5 people are sitting. Out of them, we have to find out the number of ways in case of which the tallest person is always to the right hand of the shortest person. So you see, if the shortest person ST, so we have S, T, C, D and E. Shortest person, and to his immediate right, we have the tallest person. So first, let us assume them to be 1 unit. Okay, 1 unit together. They are together. So I make a box to show they are together. So S and T are together. Fine. So now they are 1 unit. Okay, they are 1 unit. So then we have C, 2. D is third unit and E is fourth unit. Okay, so altogether we are having 1, 2, 3 and 4. 4 persons. So now N becomes 4. Please see carefully. Therefore, if 4 people are sitting in a row, now forget that S and T are different. They are now one and the same. They are united. They are connected as one unit. They will be counted as one unit. Okay. So you can see that now these guys are sitting next to each other and the tallest guy T is to the right hand side of S. Fine. So we have satisfied that requirement in the problem and we have got the other 3 guys. So this is one unit. S and T together are forming one unit. C is the second unit, D is the third unit, E is the fourth unit. So we are having 4 people sitting. If 4 people are sitting, if N is equal to 4, then the number of ways in which they can be arranged is N minus 1 factorial. So 4 minus 1 factorial, that is 3 factorial, that is 6 ways. Okay, so in this case, the correct answer is 6. So in this way, we have to solve, right? Now, please note that these guys S and T within themselves, they can be arranged in only one way, because here, if you do ST and TS, no, TS will not satisfy the equation, because TS means if I am the shortest guy, T is to the left hand side, T is the tallest guy. That is not done. That is not as per the requirement. Requirement clearly says the tallest guy is to the right hand side of the shortest guy. I am the shortest guy, the tallest guy is here. Not this way. So it cannot be TS. It has to be ST. I am the shortest guy, he is the tallest guy. So that he is on my right hand side. So this, within themselves, only one arrangement is possible, that is ST. Okay, classic question. That's why I discussed in detail. Okay. Now we go to the last one, I think, in the MTP, and then we will take 2-3 other questions and we'll take the queries as well and try to wind up at 5, almost 5. 12 school teams are participating in a quiz contest. Okay, so 12 school teams are there in a quiz contest, and the number of ways in which the first, second and third positions can be won. Okay. How many ways? You know, back those days, you know, we used to have this type of stand, right? Victory stand, we used to call it victory stand, right? In a race. So we used to call them the victory stand, and this used to be the first position. This is slightly higher, second position, this is third. So we used to stand here, a school victory stand. Now, quiz competition, first position, second position, third position. In how many ways can you do it? Let's see. 12 teams are there. Okay, so first position, second and third. First position, in how many ways can there be a winner for the first position? 12 teams, anybody can be a winner, everybody is same. So first position can be taken in 12 ways. Once one of the teams have taken the first position, now you are left with 11 teams. So that means the second place can be taken by any of the remaining 11 teams. So 11. Once the second place is taken, the third place can be taken by any of the remaining 10 teams. So you have 10. Therefore, by applying the fundamental concept of multiplication rule, right, because there are 3 distinct events here and they are interconnected events, they are dependent on each other, right? They are interrelated because you have first position, event number 1, second position, event number 2, third position, event number 3. Okay, so we have the fundamental multiplication rule, 12 into 11 into 10, that gives you 12 into 11 is 132 into 10 is 1320. 1320. Right? So this gives us the MTPs. I have solved the questions in the MTP. Now quickly I'll take 2 questions which have come from our dear students who have requested me to take it up. The first one, of course, since we have completed permutation combinations, I am taking 2 questions related to One is with related to time value of money and the other is with related to indices, right? It's a request which has come to me from Niharika from Bangalore, and the question is from MTP 2020. Very good, Niharika. Thanks to you for pointing this. May 2020 MTP, CAMTP, very important, like the ones I solved it. Today being the last day of the session on permutation combination, I took up many of the questions from the MTP and many of the questions from exercise 5B, 5C and 5D. Now I am taking up this question which has come on indices in the MTP. Please see the question. PQR, this is on indices, I am just taking it up since Niharika has sent it. PQR is equal to a to the power x. QRS is equal to a to the power y. And RSP is equal to a to the power z. Then we have to find out the value of PQRS to the power half. This is a lovely question and not a very tough one. Okay. Thanks Niharika once again. I acknowledge your name for sending the question. Okay, let's see. So let's go on multiplying. Okay, just quick. Indices is easy. PQR into QRS into RSP. So I do PQR into QRS into RSP is equal to a to the power x into a to the power y into a to the power z. Fine. Left hand side multiplication, right hand side multiplication. Done it? If you multiply this, you will find P 2 times, Q 2 times, R 2 times and S also 2 times. So it is basically PQRS square. P square, Q square, R square, S square. This is equal to a to the power x into a to the power y into the a to the power z. But you know this is equal to a to the power x plus y plus z. Fundamental law of indices, a to the power m into a to the power n is equal to a to the power m plus n. Okay. So this is this. So it's now very simple. You have to find PQRS to the power half. So you have PQRS square is this. So I can say PQRS. If a square is equal to b, then a is equal to b to the power half. Okay. So PQRS square is this. So PQRS will be what? A to the power x plus y plus z square root. But we have to find PQRS to the power half. So one more square root. Okay. So PQRS is this. So therefore I am writing here. So PQRS to the power half will be equal to what? A to the power x plus y plus z. This will be the fourth root. The fourth root. That means a to the power x plus y plus z to the power 1 by 4. Okay, the fourth root. So I think Niharika, you have followed and many others might also gain from her question. I have solved it even though it's on indices. But I didn't teach indices to you, but I thought of, since you sent me a request, it's important to solve it out to help you out. So I think you have understood the problem. The last one for today is from Tarun Pupalla from Hyderabad, and it's a question on the time value of money. Okay, I hope this solution was okay and you have followed it. He has sent me a question. I don't know the source of the question, but he has sent me the question. I am reproducing it. He has said the present value of a scooter is rupees 7290. The rate of depreciation. The depreciation rate is 10%. Fine. What was its value 3 years ago? What was the value of the scooter 3 years back? Okay. Right? So, just quickly, if you see the question, present value of a scooter today is given. It is 7,290 and depreciation rate is 10%. What was the value 3 years back? Let x be the value 3 years back. So, let x be the value 3 years back. So, we know the formula p into 1 plus I to the power n. But in this case, it is x. X is the original value. Here, instead of plus, it will be minus because depreciation, I said, starts from here, depreciate, you deduct every year, right? So it will be 1 minus d. and n here is 3. Okay, so 3. So here the formula is x, the original value of the scooter, minus 1 minus d. D is depreciation, 10%, which is 0.1. So I write 0.1 to the power 3. This is equal to 7290. X, the original price of the scooter, the cost of the scooter, historical cost, multiplied by 1 minus depreciation to the power cube is equal to 7290. So on simplifying x, 1 minus 0.1 is how much? 0.9. So 0.9 cube is equal to 7290. This comes to x is equal to 7290 by 0.9 cube. And this, if you simplify, comes to 10,000. So the original cost of the scooter was rupees 10,000. I hope Tarun Pupalla, you have heard this, you have seen the solution, and I think many others might have also got some plus some guidance as well as some light on what can be the solution to this type of problem. Friends, we come to the end, and I just quickly acknowledge few of them. Niharika's question I have taken. Manav was asking regarding rule of 72. I will just say that it's only an approximation used for quick calculation. Okay, then Anjali Panka was asking about the difference between permutation and combination. Anjali, she's from Gorakhpur. I think you are clear now. I've explained it. Megha was asking about a question. Megha Agarwal from Rajasthan. A man who takes 3 routes to go to his office and 2 routes to come back. How many ways? So it's pure multiplication. 3 into 2, 6 routes. Fine. Fatima Abdul Hamid, Palak and Tanu Tanwar, they are from Mumbai and Faridabad respectively. Sir, in practical scenario, where to use permutation and where to use combination? Now in practical scenario, they have asked a beautiful question. Fatima Abdul Hamid from Mumbai and Tanu Tanwar from Faridabad. Thanks to you for asking this question. Permutation combination is used in the area of risk management. I am a professional. I work in the area of risk management and portfolios and investments. So in that particular sector, we use a lot of these questions on permutation combination, portfolio returns, how many types of returns it can generate, how many ways you can structure a portfolio. Portfolio means a group of shares, an array of shares, debentures, bonds, financial instruments, okay. And banking, of course, we use a lot of the concepts of permutation combination. Okay, same question has come from Ishita Bhalla, Rohit Agarwal and Pratham Shah. Sir, how to know when to use addition rule or multiplication rule? I think I showed you the buzzwords by which you can identify which question is a multiplication question, which one is an addition. I explained step by step when I was using the multiplication rule. Okay, Latika from Sydney was asking how to, sir, what is factorial? I think I have explained it once again. Latika, you are clear. Yuvraj, Balvinder Kaur Gulati and Vishaka Agarwal from Agra, Faridabad and Delhi respectively have asked the question why 0 factorial is 1. I explained it in the beginning today. Aftab Sehgal from Jalandhar, if we get 270 factorial, shall we have to do the full calculation? No, Aftab, don't be worried. Such big numbers are not given in the exams. Isha Jain has thanked me for the classes. Thank you, Isha. Isha Jain from Delhi. Utkarsh, sir, will there be any tests and quizzes? Please ask Utkarsh. I think you can ask this question to BOS for their guidance. Diksha Sain from Jaipur, I have taken your question, Diksha. Pratham Purnima, Isha, Said Banu and Bharat and Akash Chauhan told me some positive comments, gave some positive comments for the drawing which I did last day about the seats. Thanks to you. You have to make it more interesting for students, and I love drawing sometimes. And Sonal, please do question number 11, 12, 13, page 5.8. I have done one of them. Prachi Gupta, also I have done some of them. Hema from Tamil Nadu has thanked me. Thank you, Hema. Jasmine Kaur was asking me how we individually calculate factorial 6 out of 3. Right, I think I explained that. And also we had Tarun Pupalla's question I took up. Kunal, how to differentiate a word problem of permutation and combination. I think, Kunal, you must have seen that in case of permutation, the order is important, but in case of combination, the order is not important. That's why we differentiated many of them while solving the problems. Then we have Sushrut Shushti Pundalik Sutar from Pune, thanking me for the classes. Thank you. Kunal from Tamil Nadu, thanking me. Thank you. B. Gayatri, Yashvi Agarwal, Utkarsh, Vishal, expressing positive feedback for the classes. Thank you. Rupangana Roy of Hyderabad has sent a question. Rupangana, I request you to please download the study material from ICAI.org. And then, yes, we have Naman Jain. Sir, we want to study a whole syllabus. Thank you, Naman. I have seen your comment. Sarthak Singla, if there are repeating letters, then how to solve? I think we did. Commerce, example like commerce, where there are repeating letters. Management, I did the last day. Calculus, we did today. Repeating letters, I think Sarthak Singla, your question is answered already. Sahil Raj from Bihar has thanked me. Thank you, Sahil. Aditi Shah from Amlai. Right. She asked for the management problem. We had a question, management, and how many letters, how many ways management, the word letters of the word management can be arranged. So question was why we divided with the 2 factorial. I think you understood that because in case of management you have multiple m, multiple n. So you have to divide the number of letters, 10 factorial, by 2 factorial, 2 factorial, and so on. Right. Finally, we have Sriman from Tamil Nadu thanking me for the classes. Thank you. Srajal Gupta had a question on management. I think I did similar problems today on commerce, calculus. Right. Please follow that. Varsha Yadav from Haryana again has expressed positive feedback on the class. And Muskan from Patna, you had a question that 1 by 9 factorial plus 1 by 10 factorial equal to x by 11 factorial, which I did and I solved it in the beginning. So friends, that's it for the time being. So we had a quick recap, we started with the permutations part. We did number of examples from exercise 5B, 5C. We once again revisited factorial. We did the difference between permutation, combination. Remember the question I had on my password in opening my bank locker. Right, then we took combination formula, we saw NCR, we saw the 2 formula NCR equal to NCN minus R plus NCR is N plus 1 CR is equal to NCR plus NCR minus 1. And we solved number of problems on the combinations part. We also did the other formula, you remember 2 to the power n minus 1. A man was inviting friends, 5 friends. So in how many ways he can invite one or more of his friends? Formula is 2 to the power n minus 1. Finally, we completed with questions from exercise 5C, 5D and the MTP May 2020. So with that, dear friends, I come to the end of today's session. A long one, but I hope a useful session. 5:15 it is. And thanks a lot for staying so long with me. Completed the chapters today. And next day, as and when we meet, we will take up the chapter on progression and number series. With that, I'm signing off. Have a great weekend. Have a great Sunday. Practice the problems. Take care and see you soon. Bye.